Please, sir. So very good morning everyone. I Deepika Sharma on behalf of IIT Guwahati welcome you all to this GIAN course on secure and sustainable computing. I extend my warm welcome to all the distinguished participants joining us here in IIT and those connecting with us virtually from across the globe. As technology continues to shape our world, the challenge before us is clear, that how do we make computing not only secure but also sustainable. Over the coming sessions, we will explore how security intersects with design enabling technology that serve both present and future generations responsibly. So, start moving with the program. First, I would like to call Professor John Josh, Head Center for Career Development and Associate Professor Department of CSE, IITG. He holds a PhD in Computer Architecture from IIT Madras and a recipient for Qualcomm Faculty Award 2021 and ComSys Younger Achievement Award 2024. His research focuses on multi-core systems, on-chip communication, IoT embedded security and hardware accelerators for MI, with over 80 publications and active collaborations with global university and industry. He is a passionate educator and outreach contributor offering popular NPTEL course in computer architecture. So now I would request Professor John Josh to welcome the audience.
Good morning all of you. To Professor T.V. Bharat, the head of CET and the Associate Dean for Academic Research at IIT Guwahati. Dr. Amit Singh from University of Essex, UK. Course Coordinator Dr. Moumita Patra from Department of Computer Science Engineering, IIT Guwahati. Participants of this GIAN course attending this program physically from IIT Guwahati and those who are attending online and those who could probably watch the recordings later. A warm welcome to all of you. On behalf of Department of Computer Science and Engineering, IIT Guwahati and Center for Educational Technology, IIT Guwahati, I propose a most warm welcome to all of you for this program. It's an honor that we were planning to host Professor Amit Singh on multiple occasions here. And even travel was planned last time when he was then associated with the Department of CSE, IIT Guwahati during the pandemic time. Unfortunately, we could not, but he gave a couple of lectures in online mode also on various topics ranging from multi-core systems to security systems to embedded devices and all. Our association with Professor Amit started maybe half a decade before, and we have collaborated also on different venues in TPC committees as co-authors of works. And it's always a great pleasure to listen from Amit, who always makes sure that every audience who is attending the event are able to grasp the concepts. He starts from the very fundamentals, take it up all the way to higher levels. So it's a great opportunity for two institutes, one from UK and one from IIT Guwahati. Maybe through this program we may have more people than trying to associate with our laboratories, with our departments from these two institutes, Amit. And since even if it's a very short tenure, we hope that you will enjoy our beautiful campus and would be able to initiate multiple collaborations which could potentially two of our countries can take it forward. From the Department of Computer Science, from electronics and allied centers, the interdisciplinary centers, there is a lot of interest in this topic of secure computing and sustainable computing. And with the kind of pioneering contributions that you had over the years, being part of technical program committee of prestigious conferences like DATE, DAC, and part of the editorial team of the most sought after journals, both from the IEEE transactions and from the ACM transactions, I'm sure your technical expertise will value add to the audience and would be able to start a new way for some of the research scholars who are very early in their stage of research in defining their problems. I'm sure security is something that is of paramount importance when India is looking forward for an Atmanirbhar Bharat, where India has to develop India's own devices. India has to develop India's own operating system to be running on these devices. And especially we are contributing heavily on the 6G stack. I'm sure there is a whole ecosystem which has a lot of potential when it comes to securing our devices. So the program is being carefully planned both by Professor Amit and Professor Moumita. My contribution is very minimal. They have made sure that it covers every aspect in and around the topic, and there are some tutorial sessions also that is being planned in the afternoons which will help the participants to gain deeper insights to this program. CSE Department IIT Guwahati formally conveys the thanks to the Center for Educational Technology also on behalf of my department head Professor Venkatesh, who is parallelly attending then another program. So I am also speaking on behalf of the department as well. The Center for Educational Technology, they're headed by Professor Bharat and his team, we're continuously working hard in making sure that we get all the support that is being required, the logistics that is being taken care of, and in reaching out to larger audience outside the institute, the live recording and everything, so that we are spared on focusing on the technical aspect. We are extremely thankful for the CET staff as well. So I propose a warm welcome to our external resource person Professor Amit to this program, to Professor Bharat, the head of the center, Professor Moumita, the program coordinator, and all the participants who are attending online and offline. I'm sure you will have a good learning experience at the end of this program, and please do make use of the breaks, the tea breaks and the lunch breaks, and try to talk with the resource persons, and that's a way how we all try to collaborate. Many greater collaborations that we see across the institutes might have started or kick-started maybe over a cup of coffee. So feel free to talk to Amit. He's a very wonderful person, down-to-earth person, and he always seeks for greater collaboration between our two countries. So with this note, I welcome you all once again for this program and have a productive learning over this week. Thank you.
Thank you so much, sir. Now, first I spare some time to introduce Dr. T.V. Bharat, Head of Center for Educational Technology, IITG, Professor, Department of Civil Engineering. Dr. T.V. Bharat currently serves as a head for Center for Educational Technology and a professor in the Department of Civil Engineering at IIT Guwahati with a PhD in Geotechnical Engineering from the Indian Institute of Science, Bangalore. He has over a decade of academic and research experience, including postdoctoral research at IISc Bangalore and the University of Saskatchewan, Canada. His area of expertise include rainfall, introduced landslides, waste management, mine trailing dams, and the geotechnical and architectural aspects of heritage structures. Along with his research contribution, he has been actively involved in academic administration also. So with this, I would like to request Dr. T.V. Bharat to address the gathering.
Thank you. Good morning, all of you. I'm very happy to be here today, and I joined by my colleagues, Professor John Jose and Professor Moumita Patra, to welcome the foreign faculty, Professor Amit Singh, and also all the participants for the GIAN course. The GIAN course, several GIAN courses have been conducted under the umbrella of Center for Educational Technology at IIT Guwahati. CET, which is a multidisciplinary center established in 2004 in IIT Guwahati, caters to many central government projects which are involved in developing digital content, also delivering skilling programs, etc. Over the years, we developed more than 750 courses from IIT Guwahati all alone for the NPTEL, which are all up on YouTube. so anybody can watch and then get some GIAN, right? So our faculty members from different disciplines contributed for these 750 courses. So we have amazing studios, editing, and a great team to develop these content. And we are still doing it. Number of new courses have been introduced in different domains. So please do go through. And also there are a number of other programs like the QIP, Quality Improvement Program. If someone is working in a AICT associated institute or college, they can come back to IITs to do their MTech or PhD, which is also administered through CET. Similarly, there's a skilling programs. Currently, for TRI services, there's a training program that is going on, which is an in-house program for their second career opportunities on drone technology. And last year, we conducted nearly 2 programs on drone technology and one on 3D printing. And similarly, we have Coursera programs. Number of courses have been organized. In this ambit, we also have this GIAN program. GIAN, the global initiative of academic networks, which started in 2015 by Government of India, essentially to enable engagement with the academic institutions outside India and bring a long-term collaborations and also exchange some knowledge or GIAN. So that is how the whole thing has started, and we are currently in phase 4. And from IIT Guwahati, we are proud that we are able to submit 20 proposals, and around 16 have been accepted. But currently, this is the 13th one which is going on, and a good participation has happened so far. And the GIAN program really allows the students or participants to engage with the foreign experts and also experts from IITs to engage in discussions and exchange in GIAN, because even if we attend any conferences, we get to speak with an expert for hardly less than an hour or so. But then here we get to spend nearly 5 days or 10 days. If it is a 1 week program, 5 days we spend together, formal, informal discussions. That way we can actually learn a lot. So that is our main motto, and I hope the experts deliver to the level of satisfaction of the participants, and enjoy your stay, and best of luck for the GIAN program. Thank you so much.
Moving forward, it's been a great honor to introduce our speaker for this course, Dr. Amit Singh. Sir currently a reader at University of Essex, UK, and also serves as Deputy Academic Lead for the Joint Essex program. He received his BTech in Electronics Engineering from IIT Dhanbad in 2006 and PhD in Computer Engineering from Nanyang Technological University, Singapore in 2013, followed by over 5 years of postal research at reputed university. His research focuses on design and optimization of intelligent computing systems for domains such as multimedia, transportation, healthcare, automotive, and cloud computing. With more than 130 publications and multiple best paper awards, he actively contributes to leading conferences and research collaboration worldwide. Now, I first request Dr. Amit to say some words for this course.
Okay, first of all, very good morning to everyone. So it's a privilege actually to come here. Like John said, I already had a Spark project with John and some faculties here, but at that time I could not travel. It was a lockdown here. So I landed in India, but then I was told you cannot come, the campus is closed. So it's very nice to come to this beautiful campus, and I'm looking forward to kind of cover, kind of like John said, starting from very basics like why secure and sustainable computing is important, and then we will build up from the very basics to more detailed technologies or approaches that are available, you can say, in the market, in the research field, but they can be applied to some real products. So, and also thanks to all the audience here and all the faculties and organizers who has made this happening. Thank you.
Now, to felicitate our distinguished guest, Dr. Amit, I would like to invite Dr. T.V. Bharat for the felicitation. Thank you, everyone. So for the thank note, I would like to invite Dr. Moumita Patra. She is an Associate Professor, Department of CSE, IIT Guwahati. Received her PhD in Vehicular Ad Hoc Network from IIT Madras in 2016. MTech in CSE from the University of Hyderabad in 2011. She worked as an assistant professor at IITH Hyderabad for 2017-2018. Her research interests includes wireless network, Internet of Vehicles, IoT, 5G based communication and a network performance analysis with affiliations to the Computer System Group and contributions to AI, machine learning and data mining. Ma'am, please.
Good morning, everyone. Security and sustainability, these are the two themes that are the way forward in today's world. And in today's course, Secure and Sustainable Computing, we intend to learn about these two aspects in computer systems. So I hope that all of you get a good knowledge, and as per your expectations, you learn about the course here. So first of all, I would like to thank Professor Bharat for helping us in proposing this course. I would like to thank Dr. Amit Singh for coming all the way from London here, and I am sure that we all will get a good knowledge here from his classes, and also he will have a very good time here. And thank you, Dr. John Jose, for helping us in creating this course. And finally, thank you to Kaushik ji for helping us in every aspect of this one. So you have been so helpful in this thing. And to all my volunteers, Manik and Shreyas, Elena, Deepika, Krishnendu, thank you. And I hope that all of you, all the students, you enjoy the course as much as you have expected. So thank you, everyone. Have a good time.
So thank you, everyone, for your kind words. So with this, I request Dr. Amit Singh to start the session. Thank you. So first we'll start with the tea break. So all of you please join us for the tea. After that we'll start the session. So we will resume the session after 15 minutes.
it's on. Hello, hello. No. Hello. Hello. I don't know. Can you hear me on the back? Yeah. Okay. Okay. So again, welcome to this course, everyone, and thanks for joining. I hope you will learn a lot of things and a topic that is highly important these days. Yeah. So like you can see on the slide, so this course is kind of designed around having computing systems and making them more secure and sustainable. Yeah. So we will be talking more around secure and sustainable, but we will be looking some other aspects of computing as well. Okay. So you already might have seen my introduction. My name is Amit Singh. You can call me Amit, and I'm from School of Computer Science and Electronic Engineering from University of Essex, which is in United Kingdom. So if you want to kind of know the geography of it, so you will see this is the map of United Kingdom, and here is London that most of the people know. Yeah, some people think UK or United Kingdom can be Uttarakhand as well. Yeah, so you have to tell like, okay, there is a London in UK. Yeah, then it's better. And University of Essex is just in the northeast direction. It's not far away. It's just 45 to 50 minutes by train. So that's fast train, and if there is a slow train, that will be like 1 hour. Yeah, so not far away, and lots of people who work in London, they live in this kind of place. Yeah, and the place is called Colchester. Yeah, so it's like University of Essex in Colchester. They have other campuses as well, but this is the main campus and where my department is there, or you can say computer science and electronics department is there. Okay. And it's called Essex because it's kind of one of a county. Yeah, there are many counties in UK, like here many states are there. Yeah, so here there's nothing like that, like University of Uttar Pradesh or University of, yeah, it's not like the name. Yeah, but this is county and then there is a university. So a bit of further introduction of myself. So I belong to a group which is called Robotics and Embedded Systems. So in my department there are mainly 4 groups, and this is one of the groups I belong to, and we have many academics and researchers. So I think we are like 8 to 10 academics, and there will be around like 25 researchers that will include postdocs, PhDs, and some master's students as well. Okay. For my research areas, so you can see I'm mainly into developing technologies that can basically improve, hopefully it's working, yeah, I think not on this. So that can improve security, reliability, power and performance. Yeah. So there are several metrics we want to take care, yeah, when we design a system. So I work mainly on these 4 metrics, but as you might have seen the title of this whole module or whole lecture, we are going to focus mainly on security and sustainability. Yeah, and in a bit we will come like how sustainability is related to power and reliability. Yeah, so sustainability is, to me, has been given new term. Yeah, and it kind of includes some other aspects as well, and in addition to reliable and power efficient computing. So when I am developing these technologies, or you might also have seen, we use lots of philosophies, yeah, or lots of approaches. Yeah, so one thing is called like design space exploration. Yeah, so it's like you start with something and keep developing more, and you end up with something. Okay, so I develop a lot of design space exploration strategies, and I also used AI based approaches. Yeah, and we will be looking into some of these in details later on, And you might also have seen there are biology inspired approaches as well, yeah. So like genetic algorithm, yeah, or evolutionary computations. So in computing, those things have also been used. I have used some market inspired approaches as well. So market is typically like you want to buy something, yeah. So you want to bid, like you want to buy something, then you say I want to buy in this much, yeah. It's kind of a negotiations, yeah. So it's like you want to buy some share or some product, and then in computing it would be like how much you are willing to pay, maybe for this server, for that server, for that server, yeah. So this is kind of market inspirations. We will cover some approaches how this can be used, okay. So you can see like while I am developing these technologies, I am typically kind of designing some advanced embedded or computing systems, and these systems can be for several applications, yeah. It could be like automotive, like a car, yeah. It could be multimedia, so like your phone has a lot of multimedia applications, yeah. You are playing games, you are watching videos and all those things, okay. And this can be used for data centers. We will be looking into it how it is used, and image processing and IoT as well, okay. So these kind of technologies can be used across many applications, okay. So if in a nutshell, actually if you look in computing, we typically need three metrics. You can say secure, sustainable and high performance computing, okay. And in this course we will be looking mainly on these two, but typically high performance is always kind of implied, yeah. So it's like you meet a performance requirement, and then on top you think how do you make systems secure and how do you make systems sustainable while meeting the performance requirement. So you are optimizing for that as well. And these are the some kind of web pages. So I have like two web pages, but this is from my university, and that one is second one is personal. You can look on those just to kind of see what else I work or what I have done in these kind of fields, okay. And this is my email ID. So if you have any questions or anything, you can always use this email ID to send me an email, okay. I don't know if you already know the outline, yes, because this was published on the website, what we are going to cover. So first we will have introduction of secure and sustainable computing, and then we will have some system design considerations and operation considerations. So I think we can quickly go to the end, just you can get the feeling what we are going to cover. And at the end you will also have the exam, that is on the Friday, 2 hours exam, and this will be like mostly multiple choice or fill in the blanks, yeah. So you don't have to describe everything in details, okay. Out of all these contents, so there are three lecturers you might have seen. So myself, Dr. Moumita and Dr. John Joes, yeah, three of us will cover these different aspects, yeah. Okay, so this is where I want to start with, just to kind of know a little bit like what you are doing at the moment and what's your name, yeah. So I think just give a moment, if there is internet it will change to something, yeah. Okay, so if you have phone, yeah, you have phone, if you can open a browser, you can just type, yeah, polev.com / Amit Singh 510. I think you can do by the barcode, but it might be too far away. So this polev.com / Amit Singh 510. So you will get a box, yeah, and then if you can type your name and what are you doing at the moment, yeah, like you are doing PhD, you're a PhD student, undergrad student, So this is to know basically how fast and slow I can go in the contents. Yeah. Can you open it? Anyone can confirm? Yeah.
So that it is written welcome to poll everywhere. Your presenter will activate questions only.
Yeah, this is activated. Let me see. Yeah. Okay.
We need to register.
No, no, you don't. I think this is how it is activated. Let me do it again. Okay. I will also try. Yeah, just. Okay, I also don't see it. Let me see. Okay. I'm trying different screen just in case it works. Anyone sees? No? No box, right? It's strange. Just give me a second. Okay, can you see now? Okay, I don't know what's happening. Okay, so like I said, I just wanted to check basically what are you doing at the moment, so we can discuss later on accordingly. Yeah. Okay. You can keep doing. I will do some changes in the setting. I think something has changed. Okay, so I see some of you are doing MTech and lots of research scholar. I also recall some postdocs. Yeah. So actually, this kind of interface gives opportunity if someone online as well wants to participate. Yeah. Okay. So junior research fellow as well. So I think we have mixed up audience from MTech, research scholar, junior research fellow or research fellows. Yeah. So I mean, what like in the lectures we can do, we can be like a bit more introductory, but for research scholars and research fellows we can go in bit more details. Yeah. So you can try to apply the same concept into your research. Okay. Good. Hopefully it works in the slides as well now. I will just check. No, it doesn't. Don't worry, that's fine. Okay, my second question, again I will go on the web. Okay. That's fine. Okay, so next thing I wanted to know, like what kind of field you are working on, yeah, and like what is your interest. So maybe like even if you are working on something, but you may want to learn something more about another topics. Yeah. Okay, this one again has some problem. All right. Hopefully you can see the interface. Yeah. You just refresh the same interface and it will just populate with different screen. Okay, AI and ML, X apps development, 5G network. Good. So secure machine learning accelerator design. Okay, good. Hardware security, IoT and edge security. So we will be covering most of the topics, and as you know, these days nobody can live without AI and ML. Yeah. So everybody applies in their own field. Yeah. I mean, sometimes it's great, it gives good results, but there could be situations it doesn't give good results. Yeah. So you can be better with heuristics approaches. Yeah. Or some other well established maybe static search. Yeah. Like evolutionary computations and all those. Yeah. So communications, I think I will be covering less of communications, but Dr. Moumita will cover some communications part. Yeah, so you will have some learning of that as well. Resource management in unmanned aerial vehicular networks. So I will cover resource management in kind of a system design, yeah, like multi and many core systems. Maybe Dr. Moumita will cover something, I don't know. So UAVs, I don't know if it's part of the project, so it's not from my side, yeah. But it's, for me, UAV is kind of another resource constrained device, yeah. It's battery operated, you cannot put a big processor on it, otherwise battery will be dying. So we will be doing resource management in resource constrained environment, and you can use the same approach other places as well, yeah. So to me it's just another kind of IoT, or you can say embedded system, yeah. So the same concept can be applied, okay. Okay, 6G, okay, again not my topic but Dr. Moumita's topic, so hopefully there will be some kind of coverage about that, okay. Okay, good to know. So lot of you are interested into kind of a small scale device or resource management or secure hardware design or communications and all those things, yeah. Okay, so good, you are at the right place, okay, yeah. Okay, I don't think this screen works, so I will go to the other one. Okay, now let's look the typical computing systems landscape, yeah, because we said we are going to cover secure and sustainable computing, yeah. So what is this computing landscape? What is computing systems landscape? So we have taken some contents from this website. So you can see here there is a lot of devices we are surrounded with, yeah, and these are typically called edge devices, yeah. So we already are surrounded with, you can say, this projector, there is AC, there will be a kind of microcontroller inside, in your laptops, in your phone, these microphones, everything, yeah. This is screen, or these are edge devices, yeah, and a smartwatch and any other thing that we are surrounded with, yeah. So and these devices typically have some sensors, they detect something and then they do some actions, yeah. For example, this air condition, yeah. So when you kind of try to decrease the temperature, so that the sensor will detect it and then it will do some actions according to that, okay. So this is one kind of computing landscapes, and if you look how many devices we have in the world, there are billions of them, yeah. So you can imagine, just maybe inside IIT Guwahati there could be maybe 10,000 devices, yeah. So worldwide there are many billions, and we are coming to that, like how many billions approximately we have at the moment, okay. After this there is another kind of computing layer. This is typically called like fog or nodes, or you can also say servers, yeah. So within IIT Guwahati again there will be lots of server rooms, right, and you may imagine why they are, yeah. It's typically because you cannot do everything on these devices, yeah. So some of the things are captured, they are sent to the server, stored, sometimes just stored, or sometimes when they are reaching there is some processing done as well. The main reason is these devices do not have memory capacity, or they are battery operated, so if you try to do everything there, it will not be done in a fast way, or it's going to take basically very long time, yeah, okay, or the battery will run out. So you have another layer that is called, you can say, servers, nodes, or fog layer, okay. And if you see their numbers, they will be in millions, yeah. So they are not like many billions, yeah. So maybe there are 2 or 3 server rooms, and each of them may have like maybe 50 or something, yeah. So you can imagine. So this is not too many. On top of this there is another layer of computing, yeah. So there is data centers, okay. So you have seen everybody uses data centers, yeah. Again the reason is some computation cannot be done here, so it's sent to the server, but there is still some computations, if you try to do those on those servers, again it's going to take a lot of time. Yeah. So you send your computation to data centers, or you can say to the clouds. Yeah. And if you look across the world, we will not have more than thousands. Okay. So if you look, these big companies, Google, Facebook, Amazon, or Microsoft, they all have their data centers. Okay. And their numbers will be just in thousands. Okay. So this is typical computing systems landscape. Okay. So now, as the topic says, we are going to look secure and sustainable computing. Okay. So we will be looking like why security is important across all the computing layer, yeah, and why sustainability is important. So you saw, like I said, what are the kind of computing devices, and these computing typically is happening on electronic device, right? Semiconductor based electronics. And over the time, if you look, we have got more and more electronic devices. Okay. So here you see, if we look like in 2018, we had like 18 billion of devices. Okay. And those are into different compartments. Yeah, you can say like some smartphones, some machine to machine, some TVs, PCs, tablets. Okay. So these are different categories. And if you look just 2023, we have like 27 or 28 billions of electronic devices. Okay. So this includes everything in from the last slide. Yeah, all the edge devices like we are surrounded with, servers, and the data centers as well. Okay. So you can see, you can kind of imagine at the moment we should have around 30 billion electronic devices. Yeah. Okay. And this is a report from Cisco, and you can basically, if you search simply this on internet, you will find this report. Maybe they have more updated version. So I created these slides, I mean, couple of months back, and you can see this is the increase is like 10% per year. Okay. But at the moment you might be seeing the news and everything, right? My feeling is this is increasing at a much faster rate. Yeah. You can see everybody now wants to create their data centers, like OpenAI, you might have heard. Yeah, you might be using ChatGPT. So you can see like they also want to create their data centers. So they want to just rack up whole servers and create data centers. So the rate is going to be much faster than 10%. Okay. And everybody is towards developing smart cities, smart homes. Okay. So on one side you can say, okay, we are doing great, it's kind of helping human, but we will see it's not helping the planet. Yeah. So it's not kind of sustainable, but how we can make it sustainable even though trying the same things, we will look those kind of things. Yeah. So some more statistics. So if we look like maybe just in a few years, like 2 or 3 years, we will have approximately 50 billion devices. Okay. That's a lot. Yeah. So you can see like we have like 6 to 7 billion people, and there are 50 billion devices. So each of us has lots of them. Yeah, 7 to 8 average. Okay. But we don't have 7 to 8, but you imagine like in companies there are like 1,000 employees, but there's a big office, there is a data center, there is server room, so they own maybe hundreds of them. Yeah, but average comes a lot. Okay. I think there is also some prediction there could be 1 trillion devices in 2 decades. Yeah. So you may know some companies that produce lot of small scale devices. Yeah, like ARM, ST Microelectronics, even AMD, NVIDIA. So these are producing like in the batch of millions. Yeah. So even I think these predictions has been from NVIDIA guys. Yeah, Jensen Huang. So there could be trillions of devices. Yeah. So you might know the story like NVIDIA was once trying to acquire ARM, and ARM is the kind of biggest producer of microcontrollers. Yeah. Even the phones that we used, most of the chips behind it, it's from ARM. So they were thinking to produce huge amount of electronics and to sell everywhere. Okay. So very kind of in 2 decades we will have trillions of these, and maybe many more thereafter. Okay. Yeah. So many electronic devices. So when we have all these, you can see like if we have so many electronic devices, this all will need electricity. Yeah. and this electricity is produced by burning fossil fuels. Yeah, so there is carbon emissions and all those things. So some sort of sustainability comes into picture. Yeah, and when there is so many devices, if they are connected, they can be attacked as well. Yeah, so we have to look the security aspect as well, and we all know there is kind of performance is the need. Yeah, first, like, okay, if you put anything, you have to make sure it's fast enough. Yeah, okay, so this is kind of the need when these devices are exponentially increasing. Okay, so I have here listed some important metrics. Yeah, so performance, the timing is the first one that everybody wants to care. Yeah, for example, if I'm clicking, like for the next slide, it should not take 1 minute to load. Yeah, like that website. Yeah, we took 1 minute to load. Everybody wants performance, which means this could be many issues. Yeah, it could be the network bandwidth, and it could be my processor is very slow. It depends. Okay, again, after performance, we want energy efficiency. Yeah, again, it has two aspects. If your device is battery operated, yeah, like my phone or laptop, we want the battery to last for a long time. But if it's not, like a server or data centers, they are taking electricity. Yeah, so your electricity bill should be as minimum as possible, and that's possible only when you reduce the energy consumption during the operations. Okay, temperature is another very important metric. Yeah, it's kind of not playing direct role into kind of your kind of energy or performance, but you may feel like if you're using your device or phone, if it becomes very hot, right, you don't feel good. That means it's important for user experience. Yeah, so temperature is important for user experience. Another thing could be so if your like device is operating at high temperature, you may realize your phone or the device will not last for a long time. It will fail very quickly. Okay, there is some sort of research on it. So if you operate at high temperature, your electronics will fail maybe in 2 years rather than 5 years. Okay, so it has some kind of reliability aspect as well. Okay, so the next one basically kind of is reliability. Like I said, temperature is related to reliability. Yeah, so it's like how long your device will last. But reliability has another aspect as well. So it's like one of the components fails. Yeah, so for example, in your phone there is many things. Yeah, like my Wi-Fi dongle failed. Yeah, then I mean my Wi-Fi module failed, then I got a dongle. Yeah, so there should be a way to work around. Yeah, so if like one component or one processor fails, how can you make sure to shift the workload to something else so you can still work around. Yeah, so this is a nice example today. Yeah, my Wi-Fi module failed, so I got a dongle, and then I shifted the workload on the dongle so we can get it done. Yeah, so basically you don't need to replace the device immediately if you can do fault tolerance. Yeah, some fault happens, how do you handle it? The next one, security, that is very related to this module. You know, security is important. Yeah, you don't want your password to be kind of known by anyone. You don't want your data to be leaked. Yeah, lots of things. Okay. Okay, I think I have this again question. I don't know if it will come on the screen. Let's see. No. So like I said, I will build up slowly. First we should get the introductions done, and then we will go into more advanced topics. Yeah. Okay, let me go to that screen. Yeah. Okay. That's fine. Okay, I see the text box. So which metric or metrics you think are the most important? Yeah, we covered 5. Yeah, performance, energy, temperature, reliability, and security. Okay, energy and power consumption, performance, reliability, cost. Okay, I think cost is interesting one. Unfortunately, I didn't put in the previous one. Thanks whoever has put it here. Because cost is something that drives everything. Yeah, if you make a kind of security solution that you sell for millions, nobody will buy. Yeah, so everything has to be cost effective. Temperature, okay, performance and security. Good. So I see some of the things around the same lines you are saying. Yeah, security is important, reliability, performance, efficiency. Yeah, but yeah, I think that someone that brought cost is good, because everything is driven by cost. Yeah, imagine like I said, someone sells you some security solutions. If it's very expensive, nobody will have it. Yeah, so it should be cost effective. And cost effective means it should be kind of lightweight. Yeah, it should not have complex logic. Yeah, it should have kind of some small software, small logic, and if it comes in form of hardware, yeah, so that hardware module should have very small footprint. Yeah, very small area, because you pay to the companies that manufacture based on what is the size of the chip. Yeah, and then if you have extra component for security, then you are going to pay more. Okay. Okay, so so like what metrics you think is the most important? So to me, actually, it kind of depends. Yeah, what kind of systems you are using. Okay. So for example, if you are in a car, yeah, like the car that are not connected with internet, right? There is no problem of computer security. Yeah, nobody is going to be connected with your car. Forget the more advanced car. Yeah, now they are connected with cloud and internet. Yeah, but those ones they are fine. They are working fine. Yeah, so in that one the most important will be performance. Yeah, so and that comes like kind of people call it safety critical systems. Yeah. So critical because you must respond to some request within a certain time. Yeah. So for example, if you apply the brake, it should respond within microseconds. Yeah. So you are applying the brake, then there is some controller that is doing some actions. Yeah. If it takes like 1 minute, then you are already crashing a lot of people. Yeah, and you don't want to kill. Yeah. So these kind of critical systems, they go under a lot of, you can say, certifications. Yeah, so it's not like you build a car, just sell someone. It has to be certified by government bodies. Okay, so for a kind of a system that is running autonomously, kind of that thing is more important. Yeah, again when it comes to more EVs, yeah, electric vehicles, now they are on batteries, right? And then kind of energy efficiency is important. Yeah, so you don't want to charge your electric vehicle every 1 hour or something. Yeah, so if you take less energy when it's running, then it can last maybe 200 kilometers. Yeah, so again it depends on the scenarios. Okay, yeah, and maybe there is some system like maybe on some kind of extreme situations like on mountains or something, right? Then maybe it's just taking some data, processing it there. Yeah, and maybe occasionally when there is maybe some storm or some kind of situation, it has to alert, it sends to the basically some servers or something for further alarms. Yeah, so in that case energy efficiency is important because there will be a battery that will be powering, and when this communication is happening, then it must be secure. Yeah, what if someone sends maybe like, okay, there is a problem, there is some landslide or something, but someone hacks the data in the middle and then says everything is fine. Okay, then there is problem. Okay, yeah, so it depends on the situation. So different metrics can be important at different places, but if you consider our normal just laptop or our phone, yeah, I would say in the phone everything, all of these is important, yeah. So when you open an app, it should be fast enough, yeah, and it should not take a lot of battery, yeah. You don't want to charge, and you don't want your phone to heat up a lot, yeah, and you also don't want your phone to just last 1 year, yeah, or 2 years. Maybe some people want it, yeah, because you want to change the phone, yeah, so you want to upgrade, yeah, but majority you don't want to change the phone, yeah, you want it to last as long as possible, yeah. If you are on contract, then you want to change, yeah, so our postpaid ones, yeah, okay, and you always want to be secure, yeah, when you are putting some data or you are doing anything, you don't want anybody to take your data, okay. So I would say it depends on the kind of environment in which you are, okay. Good. I think we need to go back here again. Okay, so I think I am going very slow, hopefully it's fine, yeah. We will go a bit fast later on, maybe when we think like, okay, this is kind of, you know about it more, but this is to build up basically how we set up the importance of the field, okay, or we set up the whole context in computing environment, okay. Now we come to introduction to secure computing. Although we have talked, but we will go in kind of more formal definitions and how people have defined and like why it is important and all those, okay, a bit more details. So if you kind of want to kind of say what is secure computing, you can say this is about protecting systems, data and people, yeah. So we talked about systems, you want it to be secure, but sometimes systems are not doing anything, there is just data stored, yeah, and it is also to protect people, yeah, okay. So just remember, like at the top level, this is not just systems, yeah, this is about data and people as well, okay, and we will come to more formal definitions and importance a bit later. So why secure computing matters, yeah, why it is important, okay. So you might already have seen lots of attack happening on different institutions, yeah, like somebody is stealing some kind of financial data or some sales data or credentials, yeah. So some of the whole organization is closed, yeah, like maybe whole hospital or maybe whole airport network, they are closed, okay. And if that kind of things are happening, there is a cost to fix it, yeah. So and this cost is projected to exceed like 10 trillion annually by 2025, just this year, okay. So this is a lot of money, yeah. I don't know if you heard this CrowdStrike company, yeah, there was some update of some systems and then everything was shut down, so like many airports and everything, although that was a security company, but they did other way around, yeah, but things can go wrong, and to fix it, it took a lot of money, yeah. Not everybody will know, but those organizations will know, okay. And recently I think in UK there has been some attacks on like some kind of retail stores. There is kind of organization called NHS, the National Health Service, there was some attack on that, and then it took a lot of money to fix, yeah. And fixing it can be in two ways, yeah. Sometimes the system is just basically maybe it has been made not to work in the way it is working, then there is a team that can go and restart and things may work, yeah. And another way to fix it, if the cyber crime happens, people want some money from it, yeah. Nobody, I mean, you can say like hackers or cyber criminals are not working for fun, yeah. They want money, okay. So they attack system and then they will kind of negotiate, you give me that money, I will kind of not do anything, yeah, or not release the data in public, okay. So sometimes there are many multi-million dollar deals, yeah. Organizations have to transfer the money to these basically you can say cyber criminals or very intelligent people to kind of sort these things, okay, yeah. So that is, this money counts everything, okay. And these breaches, you can say they cause financial damages, there is reputational damage, right? For example, you are using some kind of website, right? Maybe Instagram, Facebook or something, right? If your account is hacked, then you start believing it less, right? It has lost its reputation. That means they are not securing the things where they are storing, okay? And there is also legal damage, yeah? So like if something happens to you as part of some organization, you can basically sue the company, yeah? And then they have to pay in that terms, okay? So there is lots of basically problems that may happen because of the cyber security issues, okay? I think we already covered. So this is just an example, ransomware shutting down a hospital system. So this was a case in UK and many other places as well, okay? So ransomware is, like it says, there is some kind of malware that is put into your system, and then they have kind of control of all the systems. Then they are going to kind of ask, give me this much money, otherwise I will shut down your system. So sometimes you think like people are bluffing, and you say, okay, go ahead, and then they shut down your system, okay? And then you lost a lot of money, yeah, like pays their disappointments and all those systems, okay? Okay, so you can see how important it is. Okay, so what is secure computing? I think I wanted to hide this first, just to ask what do you think in your view is secure computing? So can any one of you just tell your definition of secure computing? Yeah, anyone? I think I already have put the definition. There is not much point, so let's look into it. I wanted to kind of put into in the same format, yeah, like previously, yeah. So I would say secure computing is basically ensuring three entities, yeah. So the first one is confidentiality, and then integrity and availability, yeah. So this is also sometimes is called CIA triad, yeah. So you know CIA in US, right? The Central Intelligence Agency, something, yeah. That's easy to remember, yeah, but it's the full form here is different, okay? It's confidentiality, integrity and availability. So what is confidentiality? Like the name says, right? You only give authorization only to the people who needs it, okay? So only authorized people should be able to access, okay? For example, the Wi-Fi network that you have in the campus, yeah, I needed to get an ID and password, yeah. If anybody can come in the network, if the network is very open, they might also do some damage, right? Integrity, second one. So integrity is again like no matter what the situation is, the device or system should work in a way it is supposed to work, okay? So it should not basically fluctuate a lot from the normal operating situations, okay? So that means that device can be trusted or system can be trusted, okay? And data accuracy and kind of trust both relate to integrity, okay? So integrity, yeah, just remember like there is a boundary for the system to work, and it should always be integrated into the same boundary. It should not do too much here and there, okay? And the third one, availability, yeah, so the systems should be accessible when needed, okay? So you don't need all the systems always, yeah. For example, I need my phone from time to time, but then it should be available, yeah. So it should not be like I put it here, someone tried to access from some network, maybe I'm connected to insecure network, and then they changed my pattern lock or something else, yeah. So it should be always available when needed, okay, yeah. So confidentiality, integrity and availability, if you are ensuring these three entities, basically you can say you are doing secure computing. And this applies to kind of three entities: hardware, software and data, yeah. It's not only about hardware, yeah, it's about software and data as well. And like I previously have said, so it kind of combines people, processes and technology, yeah. It's not just the kind of technology, yeah. There is some process as well, yeah, for ensuring security, and it combines people as well. So now let's look what is attack and what is mitigation. Yeah. So attack means like attacker is trying to attack the system, and mitigation is like kind of a solution to fix that problem. Okay, whatever the problem attacker is creating. So why attack happens? I think we already have covered. Yeah, so everything is about money. Yeah, attackers want money, or there is someone your enemy. Yeah, so you want to shut down their system. You might have heard like there was Iranian nuclear plant. So you know there are countries fighting as well. Yeah, so I think US and Israel, they did develop some kind of Trojan horse. They inserted into their system, and the whole nuclear plant was shut down. Yeah, so sometimes there is enmity, sometimes there is money. So there could be lots of things. Yeah, okay. Okay, so another thing you can say, to get sensitive and confidential information. Yeah. And what are the attack effects? So when you can get that kind of thing, so they can basically cause damages, like I already have said, financial, health, and emotional. Okay. So for example, if your password is lost, or you lost some money by someone just transferred, then there's a lot of emotional issues as well. Okay. So what could be the mitigations? Yeah. So maybe no need to discuss. Let's see. So mitigation is timely detection of these attacks and their prevention. Yeah. So why timely detection? Because if something happens, if you go to fix, like it takes long time, maybe by that time your data is not just in the hands of attackers, but it has gone many places. Yeah. Or it can basically, the whole system can be made basically not working. Yeah. So there is something called like denial of service. Yeah. So whatever the system is doing, maybe it's not doing that. Yeah. So for example, someone may attack my laptop, and then I'm not able to move my slides. Yeah. So it's called kind of denial of service. Yeah. So if a mitigation is needed, so there should be some kind of mechanism in my laptop that detects like, okay, someone is trying to access this PowerPoint, and then it should stop immediately. Yeah. Prevent that immediately, or should throw some alert. Yeah. So that I can take some manual measures maybe. Okay. So timely detection and prevention is important. Okay. So now what kind of attacks can happen on devices? Yeah. Or you can say this is devices could be computing devices. Yeah. Okay. So in broad, actually we can classify them into two categories. So the first one can be physical and side channel attacks, and another one can be logical attacks. So in physical and side channel attacks, as the name says, there is some kind of physical intervention. Yeah. For example, someone steals my phone, and then there is like, he kind of do some reverse engineering. Yeah. He takes everything in the memory, what is put, everything in the browser, and then dumps somewhere, analyzes it, maybe gets my password and lots of other sensitive data. Yeah. So there is kind of some physical intervention, and side channel is called something like, again, some physical properties are used. Okay. We will see some more examples. Yeah. So one example I can tell you here. So it's like basically not directly getting the information from the bit streams, yeah, or the information that is flowing, rather from the physical properties. Yeah. So for example, if you saw I opened a website, right, this poll everywhere, and I typed my password. Yeah. But then it's authenticated somewhere. Okay. So there are some kind of mechanisms, like when you type password like A, AB, ABC, all different combinations, the power consumption of that server will be different at different typings. Yeah, like A may be 2 watt, B 2.5 watt, ABC this watt. So all different combinations, they kind of generate different power profile. If someone can get access of that power profile, maybe they can train an AI model, like what should be the password based on different power profile. So this is using the side channel information, not the direct information. Yeah, not really looking the password, but something else that changes the physical property of the device. Okay. Another popular side channel attack is basically, you can say, acoustic, yeah, sound, yeah. I don't know if you know. So there are some attacks, like if there is a microphone in your laptop, right? If someone can get access of that, now if you're typing from the keyboard, so different keys have different level of sound, yeah, because our fingers are differently placed, yeah. So A, B, C, like if you type in a like proper professional way, yeah. So if you type A, B, C, S, all have different sound level, okay. If someone can get access of your microphone, they can get the basically the label of sound that is being generated from the keyboard. Again, from that label of sound, people can detect what is your password, yeah. So it's from the sound label. So again, this is not directly getting ABC, rather the side channel information, like what is the sound label of different keywords, okay. Then you can get the password, okay. So those kind of things happen, yeah. So the first one, like I said, micro probing and reverse engineering can be there, yeah. You take the device, you probe it, or you reverse engineer. Another one could be these things, yeah. Like I said, someone can do power analysis, and someone, like I said, someone can use the sound label, but there could be other as well. Someone can use timing as well, yeah. We will see some examples and some approach that in my group we have developed around some of these, okay. Another branch is called logical attacks, yeah. Like I said, you basically look into the channels, like maybe there is some encrypted data that is going on, and then trying to spoof that and getting the real information from that encrypted data, okay. So these can be into these categories. So basically, one side you try to basically break the encrypted protocols, and another side could be software attacks, yeah, virus, trojans, yeah, like someone puts something in my system, and then this can send some real information outside, or they can simply cause my whole system to shut down, yeah. So I should not be able to access anything, okay. So maybe this is not the perfect category, but this is what one of my PhD students did a couple of years back, and this was published in this conference, yeah. So you can look the paper for more details, and maybe it can be done in a better way as well, yeah. So this, I won't say this is the perfect, yeah.
So the attacks that happens during the time of manufacturing, like some people inserting some trojans or something, which category will it come? Will it come in the physical and sexual attack or the logical attack? And is the logical attack being called something like on the algorithm people are trying to exploit some kind of features? Is it that one called logical attack?
So I would say the one you are saying Trojan, yeah. So I won't say it's coming into that, yeah. It's kind of Trojan horse, yeah. So it's kind of being generated at runtime, yeah, because actually kind of depends. So some Trojans, like you say, when things are manufactured, people to put Trojans, right? So if that Trojan is sending some physical properties, then it comes like side channel, yeah. But that Trojan might simply do like initiating something, like maybe lots of packets in the network, and then letting the whole system down. Then it will be some kind of virus, yeah. Okay, yeah. So I think the way it's performed, it can go in either categories, okay. And the one you said, some people inserting this Trojan, we will cover that into a bit more details, yeah. I think I have lots of slides on how the Trojans can basically create some kind of attack that can let your whole system down, okay. And please, yeah, ask questions whenever you have, yeah. Raise your hand, so you don't need to wait, yeah, for the time.
I have a question regarding sound analysis attacks.
Yeah.
How an attacker come to know that which kind of information actually we are inserting? Suppose we have a user text for user information text box, for password we have a text box or something else. How we come to know that which kind of information this time we are actually inserting? Is it a password? Is it a username? Or we are typing something else?
Yeah.
And how we differentiate these sounds? Because the alphabets can be same for some text box information.
Yeah, I think very interesting question. Yeah. So for me, I think the attacker is going to get everything, yeah, maybe username, password as well, and then he is going to make some decisions like whether this can be a password or this cannot be a password, yeah. So like you said, yeah, like when I logged in into this website, right, I did put username and I also put password, yeah. So I think the attacker is going to always monitor, yeah, everything, and then he's going to decide whether it can be a password or it can be the username, yeah. Okay, yeah, very interesting, yeah. I think then attacker has some difficulty, yeah. So basically you can say defense can be like you also start putting your username in a random manner, yeah. Like it is suggested, you always put your password very long, yeah, and some random sequences, yeah, not your name, date of birth or something, yeah. If you start putting random in the username as well, especially for this acoustic, yeah, sound channel attack, it will be difficult then. Okay, thank you.
Like in sound channel attack, what will the hacker received? A sound wave means a pattern of wave or any kind of alphabet or any I can say 0 1 pattern, 1 0 pattern, anything.
It will receive the sound level, yeah. It's called like it's typically in decibels, yeah.
Okay.
So sound will happen like, for example, I typed here, right, and maybe there is another device next to it, yeah. So it can receive like the kind of level of sound I am pressing the keyboard, yeah, or
Then-
there could
then
be
he-
another program,
Then he need
That
a
is
program
stored.
to decode that pattern or
Yeah.
that sound, right?
yeah. So that program basically receives the sound level and it sends the sound level, and that sending again can be in the bit format, yeah, like binary format. I think
Oh.
sending will always happen in binary, but attacker knows this is a sound level, yeah. So yeah, so
Okay,
like
sir.
that.
Thank you.
Okay. Okay, so now coming to the threat landscape, yeah, what kind of threats can happen on our computing systems, okay. So some of it we already have covered, but we can go into maybe now more formal definitions, okay. So one category can be malware, yeah. So this is malicious software, okay. So what it can do, basically it can harm, exploit or otherwise compromise a computing system, network or device, okay. So this is a kind of malicious software that can be put into your system and can do something that you don't want, okay. And ransomware, I think we briefly looked, it is a kind of a malware, yeah, that is designed to basically get access of your files, access of your system, and then like I said, this is done basically to get money. So if you don't give the money, then the attacker is going to close your system, yeah, that in that way, okay. The second category is phishing and social engineering. I don't know if it happens here, but in the UK it happens a lot. So it's kind of representing someone like a kind of a very kind of legal person from maybe government or some insurance company or something. They call you and then they try to basically just get some confidential information, yeah, or they may say, okay, send some money, something has happened to your account or something, yeah. So and now you can see with deep fake and some everything, the voices of even maybe prime minister's voice can be copied or everybody's voice can be copied. So this is again more social engineering, yeah. So this is kind of another category and very, very popular, it's happening, yeah, okay. So they basically, attackers, they try to kind of resemble themselves as some trustworthy person or entities to trick people into revealing sensitive information and then basically getting the money, yeah. Maybe you have seen some series, Indian series, yeah, Jamtara something, Jamtara, right, it's in Bihar, yeah. It's kind of a Indian series, it's all about getting the credentials of credit cards, yeah, and people is stealing money. So there is a series, maybe you can watch, yeah. So they call it like lot of people, sir, आपका account में ये हो गया है, वो हो गया है, I need that last 3 digits and the first 16 digits, and then the money is gone. Yeah, they will say open some app, yeah, this app, and then your money is gone. So that series is based on some real events. Yeah, I think it's in Bihar, someplace, Jharkhand, Jamtara. Yeah, I watched it. It's very interesting. So you can see people can be very innovative at small places as well. Yeah, you don't need to do very high kind of rocket science. Yeah, okay. Yeah, so social engineering is is kind of getting very popular. And then there could be some insider threats as well. Yeah. Oh, sorry. So insider threats, yeah, I think like someone was saying, when these devices are manufactured, yeah, so there could be some insider, they can insert some trojans, yeah. So later on we are going to see the definition what exactly is trojan. So just I will say briefly, it's kind of a circuit that is put into your hardware, but when initial testing is done, it doesn't trigger, yeah. So it's like when maybe the cycle counter has reached maybe 1 year or something, yeah, then it will start doing something and maybe using a part a lot and damaging it, and then the whole system gets down, yeah, something like that. So some insider threats can be problem, yeah. Another thing is like, we are putting lots of IDs, passwords, yeah, it is going into some centralized system, yeah. If there is a person that has malicious intention, he can maybe erase all the data, yeah, or he can sell all the data just to some attacker, okay. So insider threats are also kind of very important, okay. And denial of service is another category, I would say. So this is basically, again, could happen due to malware or like trojans that can let the whole system down, okay. So there is some service by a system, yeah. So denial of service is simply not let that service happen, okay. Do something so that whatever person is trying to do cannot do. So it's denial of service, okay. All right. Okay, I think I need to go there now. So I have a question, what do you think are the key technologies and practices to handle threats from different landscapes, yeah? So you saw like we have typically 3 landscape, right? We said edge, the kind of devices and sensors we are surrounded with, then there is fog, like a lot of servers, and then there is data centers, yeah. But the security issues that we talked, it can be applied across all the landscapes, yeah. So I just wanted to kind of see what are your kind of ideas or technologies or practices that you can think of to handle those, yeah. Okay, so let's go that screen. I also don't know if it's time for a break or something. We will see. Let me throw that question anyway, and then is the pace fine, or you want me to go a little fast or even slower? It's okay? Okay, let's see. Okay, I can see the text box. So yeah, just you can type your question, yeah, thoughts. I think you can also type multiple times, yeah. If you cannot, I can change the setting. Let me see. Okay, as many times as they like. So you can do as many times as you want. So don't think if you have typed, you can't type again. Okay, awareness, good. So 2 people believe in awareness. Yeah, good. I think awareness is very important. Yeah, you might have seen people having annual training. Yeah, I don't know, as a student you do some training, but every year there is some training, like what you should do and what you should not do when you are working. Yeah, it's like you should always lock your laptop and you go, because this could be like information stealing. Yeah, also this is about computing systems, but in a training they also say if there is some sensitive information, sensitive file, always lock your room. Yeah. Okay, anything else you think? Awareness is good example. Yeah. So think about the previous slide. Yeah. So we said there could be several landscape. Yeah. The first one we said can be malware. Yeah. So let's say if someone inserts something into your system. Yeah. So what can you do to stop that? Yeah. And the second one was phishing and social engineering. Yeah. So awareness is for that. Yeah. So encryption is yeah, another nice way. Authentication is good. Yeah. Good. Deep learning. Also authentication, you can see, like, yeah, if there is open network, Wi-Fi network, yeah, if anybody can connect, it's dangerous. Yeah. And it's also kind of advisable, like when we travel anywhere, right, we always want Wi-Fi, right, and we connect to free Wi-Fi, and there is always a warning, like your data might be seen by someone or something. Yeah. So if you do some training, it is told never use any banking site or something. Yeah. So that kind of thing is important. Access control, yeah, that's good example as well. Like you should not be given access to every system. Yeah. So there are different kind of people who should be given different level of access. Yeah. So everybody should not have administrative right on each system. Yeah. You can install anything, you can delete anything, so that kind of thing. Quantum key distribution, that's interesting. So sorry, I don't work in quantum, so I have less kind of understanding of that. Having multiple layers of security, yeah, I think that's good. Yeah. So I mean, you can say like multi-factor authentication. Yeah. So nowadays you see, like in banking websites, right, if you type the password, then next time is you need to put an OTP. Yeah. So that's kind of multi-layered security. Yeah. As advanced cryptography for confidentiality and integrity, and AI for threat detection. Okay, interesting. I think the most popular cryptography you have seen, yeah, AES. Yeah. So this is already used. So if something better can be done, better even. Yeah. I think AI for threat detection is again very hot topic of research. Yeah. So that's very good example. Okay. Layered defense strategy and firewall. Yeah. Okay. I think layered again mean like multiple layers. Yeah. Like I said, this multi-factor authentication. Firewall is another thing. Yeah. So you don't basically allow something that you don't want into your system. Yeah. I don't know if you guys know about some kind of firewall in China. So in China you cannot open any Google and Facebook or Meta products. Yeah. You cannot open YouTube, you cannot open Gmail, no Facebook, no Instagram. Yeah. So they have kind of a firewall countrywide. None of these systems can be opened. I travel sometimes China, and you can't use even WhatsApp. Yeah. So it's very difficult, like they have their own system. Yeah. So if you can make something like this, that's also great, right? Like you don't want such websites to operate, though that may not be very secure. Yeah. Okay. Good. Yes. Is break 11:30 to 12? and then 12 to 1. Okay, so you already have shown some nice ideas. Yeah. So next, when we come from the break, we will cover more. I mean, I'm going to kind of maybe repeat some of these. If it is repeated, I will not discuss, but if there is some other points, I will just discuss that. Okay. So next slide is about kind of answer to that. Okay. So yeah, let's have this 20-25 minutes break, and then we start again. Okay.
We can start next class by 12.
Let me check the schedule. I think it is like that. Okay, I think we were supposed to have, yeah, I think we can do, yeah, let's start at 12.
There is something.
Yes, 12 to 1 we will do, yeah, and then 1 to 2 is lunch break, yeah. Okay, yeah. Yeah, 20-25 minutes. So around 50 minutes we will do more, then lunch break, yeah, then from 1 to 2. I think it's a very long day to listen a lot, yeah. So maybe it's better I keep doing slow and more interactive, yeah, so you are relaxed, okay. So this was the slide. I ask you, what do you think is the key practices, technologies and approaches, yeah, to handle security threats in different landscapes, okay. I think I need to go that other kind of slide, yeah. Okay, so some of it you already have said, so we will be quick on those, okay. So encryption, yeah, some of you already said, always have encrypted methods, okay. And strong passwords, and some of you said multi-tier security, yeah, so multi-factor authentication, role-based access, I think some of you already said that, yeah. Firewalls, I think we discussed it, yeah. And IDS is intrusion detection system, yeah, so it's like detecting some anomalies. Backups and disaster recovery, I think this is something nobody told. So you know, like, oops, I think this one, don't know what happened. Maybe I can move the chair here. I think got little movement, so some maybe this cable here. Chair just a little bit. Is there? Okay, good. So backups and disaster recovery, yeah, like we were talking in terms of ransomware, yeah, that if you don't give the money to attacker, they are going to cause denial of service, yeah, let the whole system down or stealing all the information, yeah. So if it's like someone tries to erase all the information, you should have some backup plans, yeah. That's why you may see like data center companies, they keep the data at 2 places, yeah. So if one goes wrong, they can make the system up with other backup, and there can be also disaster recovery, yeah. So again, kind of a backup, yeah. So basically you can get your data back. Regular patching and updating, this is something again I think nobody said, but you might see like there is always some kind of updates through the software, yeah. Update this version to this version, that version. So I think typically everybody ignores it because it's a lot of hassle, but it's always recommended to do it because these kind of patches are kind of going to fix some kind of advanced system problems, yeah, advanced attacks that might happen, because you know the attacks is not like this is already well established, but they keep developing, okay. So when the companies know like this is a new kind of attack that may happen, so they update their software, okay, so that can to kind of handle that. So regular patching and updating is important. I think this one someone already pointed, I think awareness, so this is just that. And security clearance of people, yeah. So you remember we said there could be insider threats, yeah. So there are some key positions, like someone is going to manage the whole IT system, has kind of root access, so that kind of person must have security clearance, yeah. I think in lots of government jobs also, yeah, you see like persons should not have any criminal backgrounds or no cyber crime or something. So you can rely on that, yeah. Still something can happen, but it's kind of an assurance that it's less likely to happen. And a strong defense is always desired. That means you must be able to detect an attack and immediately mitigate it, so that the consequences are not very kind of fatal. Okay. Good. So what are now the key takeaways, yeah, from just this introduction to secure computing? So security is everyone's job, yeah. You cannot say, okay, I leave it to the people where I log in, yeah, because they keep suggesting you put a strong password, yeah. You can think even more stronger password, yeah. So it's our job as well. I know we know it's hassle, right? Keeping so many passwords for so many websites, it's like painful to remember, yeah. But there's no other way. So this is the one we have to do. And CIA, you remember confidentiality, integrity, and availability. This is the foundation of a secure system. And we need basically the technology, processes, and awareness for a strong defense, yeah. So it's not just on the technology, we need process like rule based access, like in the previous slide I said some security clearance for the people who are going to deal with the systems, and awareness as well, yeah. So for example, if you type your kind of ID password somewhere, you must kind of be aware what exactly is going to happen with that, yeah. For example, you sign up to a lot of social media sites, right? So you should be aware like how your data is going to be used and all those kind of things. Okay. Good. Any questions on that? Introduction to secure computing? No? Okay, so with this we will move to introduction to sustainable computing. Okay. So what is sustainable computing? Again, you can simply think of like you are going to balance performance, efficiency, and the planet. So three entities together. Okay. So performance, like I said, it is always desired, yeah. So you cannot live with a system that is very, very slow. Okay. And efficiency, like again, there are efficiencies around other metrics, yeah, like energy efficiency, yeah, reliability, those kind of things. So when you are meeting your performance and also achieving efficiency in other metrics, you should think of the planet as well, yeah. So maybe you are achieving very high efficiency, yeah, or very high performance, but you may negatively impact planet. Okay. Maybe there is huge carbon footprint around it. So sustainability kind of encompass all these things. Okay. We will come to more formal definition a bit later, but just think, I think only this term has to be considered, yeah, kind of the planet, okay, or Earth, or just the campus, you can say. Okay. So why sustainable computing matters? Remember, like we said, like why secure computing matters. There is like $10 trillion cost to fix, yeah. So now about sustainable computing. So if we look ICT sector, yeah. So ICT stands for information and communication technology, yeah. So it's all around computers. So they contribute 3 to 4% of global greenhouse gas emissions. Okay, so the greenhouse gas is like carbon dioxide plus some other gas. Okay, and this can be in many form, yeah. So for example, when we get our phone or laptop, so it is first kind of manufactured in a factory, okay, at a very high temperature, and in each of these devices there are like 20 to 30 kind of materials, and they are sourced from many places, yeah. Like cobalt is the main material. This comes from Africa. There are so many other materials. They all come from different place, yeah. And then they are kind of given different form, yeah, like at high temperature. So then they release some gas, okay. and then the final product comes, and then it is transported to us, and then we start using it. Yeah. So if you look all the electronics from like kind of a resource procurement, manufacturing, transportation, then operating, maybe 4 to 5 years, yeah, each electronic. So it's around like 4% global greenhouse gas emissions. Okay. So this is the statistics at the moment. Remember, we said there are around like 28 billion electronic devices now, but there will be like 50 billion in a couple of years, and we said in a decade or two there could be trillions. Yeah. So imagine how this can increase. Yeah. Just in 2 to 3 years this can be 8 to 10%. Yeah. And then in 20 years maybe half of the world's electricity has to go in electronic devices. Yeah. And there is also some data that says, like, you know, the data centers, they take electricity like the whole of the country, like Spain or Australia. So how much energy is consumed into Australia or Spain, that much energy goes into data centers. And these companies want to expand basically at exponential rate just to capture the market. So again, there will be increase in number of electronics, a number of servers, data centers. So this greenhouse gas emissions is going to be a lot. Yeah. Okay. And about data centers, I already said, yeah. So they are high in demand, and they also consume a lot of energy. Yeah. Like I said, whole of Australia, yeah, like that goes in the data center. Okay. But why we do sustainable computing? So it's basically going to do many benefits. First could be cost savings. Yeah. Like if your data center is not taking huge amount of power, you can save energy bills. Another thing could be compliance. Yeah. So at the moment there are not of regulatory compliance, but you can see, like, you can might be here. Yeah. Like there's net zero goals for different countries. Yeah. So they all want to rely on maybe kind of renewable energy and all those kind of things. Yeah. So reduce the global greenhouse gas emissions. Okay. And ethics is another important thing. So like everybody should contribute it. So the next generations that are coming, the planet should be livable for them. Yeah. You can imagine there are a lot of places already on earth, its temperature is so high. Yeah. So even you may imagine when we were child, and now the rise in temperature is a lot. Yeah. And this is going to increase. So everybody has to think in sustainable way. Okay. So just imagine, like, we have trillions of electronics, and then how much electricity in the whole world is going, half of that is going to electronic devices. Yeah. That's too much. Yeah. Okay. That is why you can see, like, there are a lot of regulations coming, and if someone is more carbon neutral, they are incentivized, like they can get some carbon credit and all those things. Yeah. EVs are coming because of that, so you have less gas. Yeah. Okay. Okay. Let me see that slide again. This one is done. Okay, I think briefly we have discussed, but I just wanted to kind of have your view. What do you think is sustainable computing? If you can think maybe slightly different what we talked, yeah, that will be more interesting to discuss. Yeah. So some kind of I'm looking more formal definition. Yeah. So when I was saying what is secure computing, so it was about ensuring CIA, yeah, confidentiality, integrity, and availability. So can you say something like that? Maybe ensuring this. Yeah.
Ensuring efficient energy consumption.
Yeah. Okay. Let's read. Yeah. Sometimes actually a lot of interesting thing comes from discussions. Yeah. So long lasting and eco-friendly, definitely. Yeah. So you want maybe your laptop to last I think there are some researchers, they want to propose in a way like, you know, your electronic lasts for whole life, 100 years, and it consumes maybe no energy, or just solar something that is enough from the solar. This is the best, right? Then you're not burning any fossil fuel. Yeah. Okay, long lasting, eco-friendly, good. Focuses on minimizing the risk to planet. Yeah, this is the, yeah, I would say that, yeah, this is what we want, right? We want to do something for computing devices, and it should have low risk for the planet, or it should have no risk for the planet. Okay. So producing and using computing devices in a way that causes minimal effect on resources of the planet towards a net zero effect. Okay, I think if you put that answer in the question, you get 100 marks. Yeah. This is like, yeah, quite formal definition. Good. Yeah. But I think lots of definitions are kind of around the same line, so it's not like only one definition is perfect. Yeah, could be, yeah, that one is also good. The practice of designing, manufacturing, using, and disposing of for optimal use. Okay, so this one is very much matching to the slide I have. Next one, where I have put my definition. Okay. Okay. Yeah. Good. That's nice definitions to see. Okay. So the okay, another one. With finite planet and finite natural resources, computing cannot be infinite in resource consumption. That's correct. Yeah. Okay, I think it's kind of coming along the same lines. Yeah. So you can see there is a lot of this mineral war, right? Mineral deals. Yeah. So I don't know if I should say, because it's getting recorded, but countries are fighting for minerals. Yeah, US wants some Ukraine minerals. Yeah, because there are a lot in China, and lot of these are going to be used in basically computing devices. Yeah, so there are limited minerals. Yeah, I think at the moment a lot of minerals that come in computing devices, most of them are from Africa. Yeah, I don't know if you have seen any videos or something. The kind of mining that happens there, it's kind of very unfriendly or environment where people work in. So it gets everything procured mostly to kind of China or Taiwan. Yeah, this TSMC you might know, Taiwan Manufacturing Semiconductor. Yeah, so they produce all the chips for a lot of companies. Okay, yeah. Definitely there is limited resource. That is why you can also see there is a research to have computers based on some other device, yeah, not on electronics. Yeah, so some other kind of materials. So material scientists are working on all the directions. So having computers from other materials that are available in abundant on the earth. Yeah, not just semiconductor. Okay, good. So let's now look my definition, and I think I said it matches to one of it, right? Yeah. So designing, operating, and disposing of computing resources with minimal environmental impact. I think this one matches to one of them very closely. Yeah. Okay. So when you design, when you operate, when you dispose your electronics, always think of having minimal environmental impact. Okay. You can't do the designing, yeah, but some of you do research into kind of making a new chip, yeah, for a specific system. Then you can always think of like how you use minimum hardware, no need to use so many hardware. Okay, and then when you are operating it, making sure it does not take a lot of power. Yeah, for example, my laptop, yeah, you can see there is some brightness level, yeah, and there is some frequency at which the processor is running. So my brightness should not be the full always, yeah, and my frequency of the processor should not be the highest, otherwise it's just taking more and more power. Okay, similarly everywhere, yeah, wherever electronics are used, just find the most appropriate level so that you can deliver what is needed, but do not over consume anything. Okay. And examples, I think, like Dr. Moumita said, energy efficiency when you are operating, hardware life cycle management. I think this is something, there is a lot of research happening, but it's very less in practice. Yeah. For example, if something goes wrong with my phone, so there's no life cycle management. Yeah. I think on internet, on Amazon or maybe on Flipkart, you can see there are some refurbished phone or something, right? That is some sort of life cycle management. If something goes wrong, you kind of refurbish it, right? But there is also a way, if something goes wrong, if you can't refurbish, maybe by replacing some computing part, you can remanufacture it. Yeah. And there is another step, if you can't remanufacture, you can basically recycle it. Yeah. So crush everything and extract all the useful parts. Okay. So this kind of things has to be established. Yeah. And there's another important thing like long lasting electronic. Yeah. Someone said like what we can do. So this maybe I want my phone to last for like maybe 10 years or something. Like I said, not everybody wants. Yeah. Everybody wants to replace it. But if it's going to last like 10 years, how the companies are going to make profit? Yeah. So it's not simply just extending the lifetime of electronics. It's a lot of things are around it. Yeah. So you have to change some business model and everything. Yeah. So maybe companies charge a lot of money at the beginning, but if anything goes wrong with it, they have to basically replace it or repair it. Yeah. And then there could be some kind of economy around repair, yeah, or replacing. So if you put any company, your phone, laptop must last 10 years, then they are definitely going to kind of make sure, yeah, it will last longer. They will repair or something, but then they want initial upfront cost a lot. Yeah. So you may know like the aeroplane engines that Rolls-Royce make. So you can see like there is a lot of orders of aeroplanes, right? But these engines cannot be made so frequently. So Rolls-Royce, like this fighter jet engines model is more on this one, like initial a lot of upfront cost and then more around repairing. So they charge a lot of money around repair. Yeah. So so basically aeroplane's engine is not changed every 2 years or something. Yeah. It lasts many years. Okay. So something like that. So that something like that has to be done, but I think it's still far away. Yeah. Because things are available. Imagine there is no silicon available, then this phone will be maybe 1 lakh rupees, and then these things will start happening. Okay. Yeah. And responsible e-waste handling. So later on we are going to see, so there is lots of electronic waste that happen. So how we can make sure it is done in a responsible way. Yeah. So maybe simply not throwing my phone, rather using it for some other purpose. Yeah. Maybe it's just data entry logging. Yeah. Maybe some in a supermarket someone can use it for some purpose. Yeah. Or maybe I can use its camera simply to monitor something. Yeah. So if it's a kind of repurposing, yeah, you can do the repurposing of the electronics. Yeah. Okay. So again here we have, you can say, 3 pillars to balance. So we have environmental sustainability, so we have to reduce carbon footprint. A bit of this we have discussed, economic sustainability. So again we need lower costs and improve efficiency, and we discussed a little bit of economic aspect. Yeah, how you can basically have some economic policies around it. Social sustainability should also be there. So there should be fair labor and digital inclusion. Okay. So these are the things that we need to kind of do so that we can do sustainable computing. Okay. So what are the key environmental challenges? Okay. So one, like I said, data center energy use. Yeah. It's like I said, whole Spain that is taking electricity, same amount goes in data center. So how we can handle that? So that's the challenge. Electronic waste is another challenge. high resource consumption in manufacturing. Yeah, like I said, there is lots of resources in manufacturing. So how do we make sure we take less resources? Yeah, like we don't you put so many things into the same electronics. Yeah, if it's not needed. Yeah, and the water uses for cooling. Yeah, so you know in data centers or this factories, there is huge kind of amount of water that is used for cooling. Yeah, and you know we have less and less water or less and less good water, good quality water. If we waste a lot in cooling, then we will have impact on the planet again due to water. Okay, yeah. Okay, now let's look some again statistics on carbon emissions by electronic devices. Yeah, so if you recall, I said around 3 to 4% is used by all the electronic devices. Yeah, but if you look like all the sectors, yeah, maybe like oil industry, car industry, something like that. Yeah, so if you look electronics, they are the like at 8th position. Yeah, so they are in the top 8 sectors, and this one accounts for 50% of the global carbon emissions. Okay, so basically if you take all the top 8 sectors, they are like for 50%. Yeah, but for electronics, like I said, they are around 4%. Yeah, 3 to 4%. So this one I already have said, globally computing devices are responsible for about 4% of world's total carbon emissions, but most of it is for data centers. Yeah, so you can see 1% of the world's electricity is going into rest of the things, like in this laptop, projector, fridge, TVs, smartphones, everything. Okay, yeah. So now let's look waste by electronic devices. Yeah, like I said, there's a huge waste. Yeah, so to look some statistics, so that the current contribution is over 50 million metric tons of electronic waste annually. Yeah, so this is again worldwide. Okay, so this maybe this figure is not very much relating. So if you want to relate like how much it is per person, so it's around 7 kilogram per person. Okay, so let's say 7 billion people, and then it's each of us have around 7 kilograms of electronic waste every year. Yeah, but like I said, this is not something that we do a lot. There are companies that have huge amount of resources for data centers, facilities and everything. So if you count, it can be like that. Yeah, so for example, like let's say whoever is part of IIT Guwahati, yeah, there are so many computers, yeah, in labs or server rooms, lots of monitoring cameras and everything. Yeah, even though you are not having all of it, but you are sharing it, right? So maybe each of you have like 2 or 3 kilograms. Yeah, so I would still say like in developed countries it's more because they have more money to put, but average this is what it comes out. Yeah, okay. Again here like I'm saying 3-4 kilograms. Yeah, but if you go to a village, maybe there is just 4 laptop in a village, right? So their footprint e-waste is very less. Yeah, but if you average out, this is what it is. So that means some people have maybe 100 kilograms per person. Yeah, some organizations. Yeah. So this is fastest growing waste stream globally. Yeah, so you have seen this plastic waste, yeah, or those kind of things. So those are still at a lot. Material like building material waste, buildings are like crashed after some time, they are still a lot, but this one is also growing very fast. Yeah, so there needs to be kind of some mechanisms basically how to recycle, refurbish those things in a better way. And this carbon emission and waste will kind of exacerbate further due to exponential increase in the number of devices. Yeah, like I said, we have around 28 billion, in a couple of years 50, and then many trillions. So this kind of waste will be even more and more, yeah, per person, and thus this is going to significantly impact the sustainability of our planet. Okay. So maybe with trillion of devices, per capita might be 100 kilogram, yeah, electronics. Okay, so now I have this question, so let me go that slide. Okay, so this is some performance issue, yeah. I said things should be high performance, but maybe it's my laptop or the network. Okay. Okay. Someone already typed. Okay. What? Okay. So what is sustainable computing? That is why. Yeah. Yes, this one is the one. So what can be done to achieve sustainable computing? So you see the trend, right? I said at the moment there is like 7 kilograms electronic waste every person, yeah, and the data centers are consuming 3% of the world's electricity, yeah. So if you search on internet, there might be different quotes, yeah. So I have got it from some source. So if this number of electronics are going to increase like maybe 1 trillion, what do you think can be achieved, yeah? What can be done basically to kind of achieve sustainable computing? Okay, eco-friendly devices, interesting. So basically that the devices that take less and less power, yeah, or maybe kind of made in a way they don't have a lot of electronics into it, yeah, just needed. Recycling is good, yeah. Be responsible about e-waste individually, yeah, that's good. So I think in the latter part of the lectures we are going to talk more about what we can do at computing level, yeah. So here as part of the introduction I just want to kind of set up in a broader context, yeah. It's not just about computing, yeah. So recycling and repairing is important, yeah. So leverage it virtualization and cloud and edge computing to optimize resource utilization, yeah. That's good. Basically it's towards kind of doing more with less resources, yeah. So you don't basically have extra resource unnecessarily. Okay, love your digital devices to reduce e-waste, of course, yeah, very good. So merger of chemical industries with electronic waste to recycle, that's interesting one. I think yeah, it's still like lots of electronics, you know, it's just dumped in the sea. So I mean at some point it will start happening when things become expensive and there are less and less material, yeah. So at different levels being mindful of resource uses, recycling, alternative bio resources, reduce power and energy consumption, interesting. Yeah, recycling we should do, alternate resources, like I said some material scientists they are trying to develop computers based on other materials, yeah, not really semiconductor, yeah. Reduce power and energy consumption, that's a good one. Raise awareness for eco-friendly computing habits, yeah. Yeah, I think this is good one. So like for example if you go somewhere, your TV is on, just turn it off, yeah, your laptop is on, turn it off. Although all these are like 1% of the world's electricity, but it will reduce carbon footprint, yeah. Or we go out, then all the ACs should be turned off, yeah. They should not be just running here if there is no one, right, yeah. Okay, good. Don't misuse resources of electronic devices and aware to use, yeah. I think this is along the same lines, okay. Okay, that's quite good example, yeah. So I think now you know what to do, yeah. Don't throw your electronics, yeah. Try to use as much as possible, yeah. I am using this laptop like from 7 years, so that's why you can see my Wi-Fi modem has died. Although, yeah, I have kind of a backup laptop, but I didn't pack it, yeah. So I try to use as much as possible, and my phone is also, I think, 6 or 7 years old, yeah. I think there's another reason. I mean, there could be two reasons, yeah. One, you are like environmental friendly. Another is you don't want to change, yeah. You don't want to update the software and everything, yeah. So I think from both the point of view, yeah. First of all, I don't want to install so many things on a new device, and second, I think like, okay, it's new phone is not attractive to me, yeah. So maybe it also depends on your age where you are. If you ask someone like maybe 16 or to like 25-year-old, they may say, oh, no, I want this advanced phone, yeah. I think that's not bad, but if you can make sure the one that you are leaving that goes in someone's hand, yeah, and then it is used for a long time, yeah. If it just is thrown in the bin, then that's electronic waste, yeah. Okay, good. Okay, so now I will kind of go through, like, you already have said what can be done. So again, like, if something has been discussed, we will just move quickly. If there is something new, we can discuss little bit more, okay. So energy efficiency is first. I think this is something already covered, yeah. You can have low power hardware design or energy efficient uses and processing, okay, yeah. And this is one example here, like Google data centers. Like I said, data centers take a lot of power, yeah, or electricity. So Google used some cooling system based on AI that reduced energy use by 40%, yeah. So you can imagine, like, this is a huge reduction, right? So if all the data centers do something same, so if it's like 3% of world's electricity, it will be simply like half of that, yeah. So that's kind of very good use. Life cycle thinking, I think some of you already mentioned it. Circular economy models, I think this is what I discussed. So you have to think recycling, refurbishment, all kind of programs, okay. But the thing is, this refurbishment has to be incentivized some way, right? If you refurbish, like, what do you get out of it? Maybe you can get some incentive, yeah, or the people who are doing the people who are repairing, they need to be paid higher, right? If they are not paid, well, they will be like, why I am repairing, right? Yeah. Long lasting, we have discussed. Renewable energy adoption, yeah, this is what we have not discussed. So you know, like, there are a lot of renewable energy from solar, wind farms, solar panels and all those, right? And the energy that is stored from them is not always available, okay. So whenever it's available, that should be used in the electronics, okay. So, and implement green policies, yeah. So for example, audit energy uses and incentivize accordingly, yeah. So I think in some kind of European countries, it's already being done. So every organization is asked, what is your energy use? So like, how much is this computer is using, how much is this office using. So if they somehow can show their energy use is less, they get some incentives, yeah. So like reduction in their energy bills or something. So again, if you are incentivized for something, you tend to do it more, right? So that is why it's important. Okay, so now some key takeaways. So what is sustainable computing? So it's about achieving efficiency with responsibility towards the planet, okay. And every choice impact footprint, yeah. So whatever you do, if you have electronics around you, the kind of path you choose, it impacts the footprint, okay. And technology can be part of the solution, yeah, but it is not the complete solution. You remember we said it's just not the technology, it's like human as well has to be part of it. Okay, any questions? Yeah, any more questions? Yeah, hope you get some idea, like introduction to like secure computing and sustainable computing, yeah. So, I think this kind of material you can find at many places, but this is something like I took from many sources and then combined the kind of work we do as well. Yeah. Okay. Okay. So, I think we have exceeded the time. The plan was this much we are going to cover in lecture 1, yeah, but I think we have used part of the time on lecture 2. So, I think I will try to basically maybe not repeat the things if it is again available in the next slides. Yeah. Okay, so this should be not taking long time because we have only 15 slides for lecture 2. Okay, so for lecture 2, the plan is to basically learn about system design and operation considerations for secure and sustainable computing. Okay, so this is what we want to do, right? Secure and sustainable computing. And when you can basically do that, yeah. So you are designing the system, and then you are operating the system or using it. Yeah. So either you can do during the design, or you can do during the operation of the system when you are using. Okay. And the focus is mainly secure and sustainable computing. Okay, so the first we will look system design and operation considerations for secure computing, and after this we will look for the sustainable computing. Okay, so again I have put some questions, and sorry I have not put in that format because like I told you, my internet modem has stopped working. Maybe tomorrow I will bring more this kind of questions. Okay. So how security attacks originate from system design and operation point of view. So let's say you are designing your system, or it's being manufactured or designed somewhere, and then you start using it. So how security attacks originate? What do you think? I mean, few things we already have seen, right? When you are operating, someone can put some malware into it, right? That's one way. Yeah. Any other things you can think? I think someone mentioned in the first lecture, like when things are manufactured, someone can insert hardware trojans into it. Yeah. That's another way to originate, yeah, security attacks. Say again? Keyloggers. Yeah, that could be, yeah, one way. So again, if you look the security landscape we discussed, right? We said malware, social engineering, yeah, insider threats, denial of service, yeah. So again, that insider threats can always be there, yeah. Someone in the organization with malicious intention, they can always put a virus in any computer, yeah. So it can originate in many ways, yeah. When basically it's being designed, so someone having bad intention, they can put some kind of extra circuit that can trigger some operation after some time and letting the whole system down. Okay. And when you are operating, again someone can insert some malware, and like we discussed, there was a branch of attacks, right? I said side channel attack. Someone can always get his side channel information to get passwords or something. Okay. So now let's look some top reasons for security attacks. So I would say, I mean, this is my definition, but you can think from different point of view. Yeah. So one thing is, if we are starting with a compromised hardware, yeah. So a system is basically couple of things, yeah. You have a hardware, you have a software, right? And then this hardware is integrated with the software, and then it does something, and then system is operating. Okay. So if you get a hardware from, let's say, Intel, AMD, some companies, or NVIDIA, if that itself is compromised, yeah, that has a hardware trojan, yeah, or maybe a circuit that sends information over the Wi-Fi network. Yeah, that is a compromised hardware. Yeah, so if you start with a compromised hardware, then this is a problem. Yeah, another thing could be you may start with a compromised software. Yeah, for example, you install something, maybe some AI module or something, and that itself is compromised. Yeah, or it has some kind of malware into the package. Okay. So, like I said, think like system has kind of two components, hardware, software. You integrate them to start running the things. If any of those is compromised, you will have security issues. Okay? And the next one can be bad actors in the middle of execution. Yeah. So, when you integrated hardware, software, you are executing something. Like I said, now this PowerPoint is running. Now it's executing basically. Yeah, this program is running continuously. But if there is some bad actor, that means someone tries to get access of my computer, or there could be some other ways to kind of do some kind of attack onto it. Yeah, maybe putting some virus in the meantime. Okay, so these are the three kind of you can say places where things can happen. Yeah, so again, this is my definition, that's how I think, but if you look in the books, everything, they might be in different ways. Okay, all right. So think like, do not start with a bad hardware. Again, there is some reputation, right? Like some companies have reputation, that is why you choose that company's hardware. That's the reason. Again, software as well. Yeah, you do not install anything on your phone, right? You go Apple Play Store or Google Play Store. Yeah, you can get lots of APK files on the web. You can always put into your phone. Yeah, but then something may go wrong. Okay, yeah, and if something happens in the middle, we already have seen. Okay, so what should be done to kind of basically to stop these? Any thoughts? I think some of it we already have discussed, right? So maybe that's I said, yeah, I will not try to repeat, we will go quickly, but maybe again thinking like we already have discussed few things, what extra do you think is needed to achieve this secure computing from the point of view of design and operation? Yeah, maybe let's look what I have. Yeah, so you can always do something called like network and device segmentation and isolation. Yeah, so you might have seen like there is some technologies in some products. I will come to that later. So you know, if there is a kind of more secure data flowing, so that kind of network can be isolated and not everybody should be given access to it. Yeah, so that is kind of segmentation and isolation of the critical parts, critical data, critical system. Yeah, even it comes to critical people as well, right? So like director of the institute, registrar of the institute. Yeah, they live in a more secure place or something. Yeah, it same happens with systems or data. Yeah, if it is more secure, not everybody will have access to it, and they will be isolated from rest of the things. Okay, and we can also have trusted execution environment. I don't know if you have heard, ARM has developed something called like trust zone. Okay, and Intel has developed something like Intel SGX. Okay, so this is something like in your phone, let's say typically you have 8 processors. Yeah, so they kind of develop some zone, like 4 of the processors will be one zone, another 4 will be another zone, and this first 4 will be called like secure zone. So anything confidential that happens has to be in the secure zone, rest of the things can be on the non-secure zone. Later on I am going to kind of have more detailed approach that we have developed in our group, how these things happen and how then attack can happen and how the defense can happen a bit later. Yeah, but this is what you can think of. Yeah, so kind of trusted environment where not every application will have access to it. Yeah, only kind of more authenticated applications will have access. End-to-end encryption we have seen. data encryption at rest and in transit. Yeah, so it's like when data is just sitting, then also encrypt it, and when it is moving or going from one place to another, then we encrypt anyway. Okay. Regular updates for OS, firmware, and apps. We have seen it. Yeah. But the one thing to do is always test patches before deployment. Yeah. I think this is not everybody can do. So you need to have some kind of expertise into it. That is why when we get some software update or something, that is already kind of tested. Yeah, maybe if it's provided by some security company, or if it's some update from someone like an app, it's already tested by Google apps. Yeah, or you can say, yeah, other companies. And appropriate access controls, we have seen it, and continuous logging and monitoring. Yeah, so this is important, but again it depends on the situation. If you kind of always monitor, like in my laptop, what's happening. Yeah, if it's monitoring like every minute, I'm just running my PowerPoint slide. Yeah, but this is not kind of very useful. Yeah, but it could be like if some attacker tries to access my system, then if you're logging, then basically kind of do some processing of that logging, and then you can flag like there is some kind of suspicious activity or something. Okay, so this can help in kind of stopping security attacks. So this is very, very typical to kind of physical, right? When you enter some buildings, they ask you to write the name. Yeah, when you came. Yeah, that's logging. Yeah, when you go, then also you check out. That's kind of monitoring. So in that process, basically they can find out like there could be some kind of suspicious person or something. Okay, and there are cameras to monitor. Okay, similarly think the same can happen into electronic device. Yeah, when someone comes in, they must be authenticated. Yeah, and then whatever they are doing, they must be monitored by a camera. Okay, but in computer there is no camera, so it's just kind of some events that can be monitored. Okay, so what extra can be done? Anything else you can think of? Anything extra you can think of? Okay, I think we have covered most of it, but I will tell you just few things. So let's say like some security attack happens, right? Sometimes you can do post incident analysis. Yeah, like sometimes some robbery happens. Yeah, and then it's not stopped. Yeah, it has happened, but police is looking recordings and everything, so that they can put some mechanisms, so in future it doesn't happen again. Yeah, they will put some cameras on some security guards. Yeah, similar happens in computer. Yeah, something happened, do the analysis and think like when it happened what you can do. So it's like after the analysis you may think I can do monitoring like maybe every minute or every hour or every second. Yeah, so this kind of mitigations can be done. And there is also, you know, like kind of a continuous security testing. Yeah, so there should be some kind of software. It should always, maybe on a regular basis, every monthly or something, it should keep checking whether there is only authenticated applications running. Okay, those kind of things can be done as well. Yeah, similarly it's done in kind of in the physical world, right? So it's always kind of I mean, on a regular basis it is checked who are the people working into this, if anybody has done any criminal activities or something. Yeah, every year maybe there can be an audit. Yeah, okay, that's about that. So now key takeaways about the system design and operation for secure computing. So you can see here security is a life cycle. We have to think not during operation but at design as well. Yeah, and we have to keep thinking it. Okay, and threats evolve over the time, so therefore defenses must evolve. Okay, you can see like every day there are new types of threats or new types of attacks. Okay, so you have to think the defense in the same way. Okay, and integrate security into every phase. Yeah, so not only like design and operation, rather like I said, audits, regular updates, and all those kind of things. Okay, any questions there? Yeah, I think it's very generic. Yeah, maybe you do not have questions. Like I said, later we will go into more like the kind of approach, then you may have some questions. So now let's look the same thing, design and operation for sustainable computing. I don't know if we are up the time. I think we have 2-3 minutes. Yeah, let's do it. Yeah, so for sustainable computing. Yeah, so again I try to put always questions so we can interact. So how sustainable issues originate from system design and operation point of view? Yeah, I think some of it we have discussed. Yeah, like if you are irresponsible, like you are not aware, like we are doing so much carbon footprint. Yeah, so unawareness, kind of irresponsible behavior, those kind of things can be there. Yeah, so let's look at. So top reasons for sustainability issues. Yeah, so one is rising hardware demands. Yeah, so you saw the curve, right? The number of hardwares needed are a lot. Yeah, and nowadays you can see like NVIDIA is the kind of most valuable company. Yeah, $4 trillion, I think $4.5 trillion. They got only because of rising hardware demands. Yeah, everybody wants GPUs. And they have so many orders. Even the top companies like Google, Facebook, Amazon, Microsoft, they are buying their hardware. Yeah, they are making NVIDIA more rich. So, and this is like they are producing more and more hardware, and that's not good for sustainability. Yeah, and why this is happening? It's mainly because of the rising software demands. Yeah, we want more AI processing onto these hardware. And we want more streaming. Yeah, like Netflix, Amazon Prime. Yeah, everybody wants to develop their own platform. Yeah, YouTube. So lots of AI processing, lots of streaming on these hardwares. Okay. Sorry.
Better communication hardware.
Yeah. Communication hardware. Yeah, they are also. Yeah, I think. Yeah, that's the thing. So hardware is. I mean, we are talking mainly computing, but there are communication hardware as well. Yeah, so there are upgrades into the routers, communication hardware as well. Okay, yeah. Okay, these are the top reasons. Yeah, we want more hardware. The reason is there are more complex AI algorithms and more streaming and everything to be done. And also, I saw there are lots of apps to do the same thing, right? And sometimes we have all the apps. And we really don't need it. Yeah, and so basically we should not install unnecessarily apps. Yeah, okay. And this AI is kind of a race nowadays. Everybody wants their own chatbot. Yeah, Google has their own. Meta, now in Facebook as in WhatsApp as well. Meta has integrated. You can ask anything. But essentially everyone is doing the same. Yeah, Microsoft has Copilot. So this is not really needed. Yeah. But it's kind of business model and everything. Nobody can stop. Yeah, so there will be rising demand for hardwares, and because of the rising software needs. So this is going to happen. So what should be done? Okay, let's look. So first thing we could think of is hardware efficiency. I think some of it we have discussed. Yeah, so no need to go through again. We should have energy efficient CPUs and GPUs. Okay. And there is something called adaptive performance scaling. So it's like if my CPU doesn't need to run at the highest frequency, I should run it at the lower, so it consumes less power. We should have modular design. Yeah, so it's like there are many modules to make one system, but if one module fails, you replace it with something else. Yeah, so you can upgrade the components easily. Data center and infrastructure, again this is important. So one thing that kind of can be done in place of processing the data on the cloud. You can try to process as much as possible on the edge. Yeah, it's like near the sensor, yeah, where the data is collected. But because there is not enough resource, there is limited resource, that is why data is sent to the cloud. Yeah, imagine the example of this Google Maps. Yeah, you cannot run it if there is no internet. Yeah, so it's kind of when you zoom in, if there is a local map is stored, it will work. Yeah, but you cannot store the whole map. So when you zoom in or zoom out, there is a request that goes to the cloud, and then there is a response. That is why you get kind of zoomed in or zoomed out image. Yeah, because that kind of thing cannot be done on the local device. Okay. There could be more advanced cooling. Yeah, so you saw this Google did some advanced AI based cooling, right, and that reduces their cooling cost by 40%. So that kind of thing can be done. And network segmentation and isolation, this is kind of related to security, if you remember. Yeah, again for software design, yeah, similar to hardware, we should think about the software as well. We should not have a very heavy software for doing something very small. Yeah, so you might have seen this in your BTech, order of n square. Yeah, order of n cube, order of something. Yeah, so you should always have lightweight software, so it doesn't take a lot of power. Okay, there is something also called energy efficient coding. I think no software programmer does it. Yeah, so they just care about the functionality, but now this kind of research is picking. So you know, like let's say if you have two entities, like two operands A and B, yeah, two variables. So A has like 12, maybe B has 10. Yeah, although if you multiply 12 by 10, it's 120. Yeah, so if you do 12 by 10, the power consumption of that is different than 10 by 12. So the kind of order in which you multiply, their power consumption is different. So this is called like energy efficient coding. Yeah, so some people know it, some people don't know it. So let's say if you are multiplying 3 values and you always know value of variable A will be highest, you should always put that on the first left hand side. Okay, so this kind of practices needs to be done to kind of, even if you are not making the software lightweight, but you are making energy efficient codes. Okay, load balancing and scheduling to minimize waste. Yeah, so you always know, like we kind of try to do things in as minimum resources as possible, and to meet the performance requirement, sometimes we have to do load balancing. Yeah, okay. Okay, I think we will stop on this one after just doing this. So network and storage design, so we can do efficient data routing to reduce hops. Yeah, so data doesn't have to travel a lot, because if you're traveling a lot, you are burning fuel, you can say. Yeah, and there could be storage tiring, so hot versus cold data. Yeah, so hot data is something like you always need that kind of data. That is why in computer you see there is memory hierarchy, right? There is cache, then DRAM, yeah, and there is multiple level of cache. Yeah, so that is basically storage tiring. Yeah, so if you are accessing something more frequently, if it's near the cache, it takes less power. Yeah, and if you go to the main memory, then basically it takes more power. So this is something I like an example someone explained in a way, you know, like you need some food, right? So some people get the food from the supermarket, put in the fridge. Yeah, so if you get it from the fridge, it's like your cache memory. Yeah, but it doesn't have a lot of space. Yeah, it's fast, you don't travel, you don't have a lot of carbon footprint. But some of the things are not in the fridge. Yeah, so the one that you need frequently, you put in the fridge. Yeah, maybe milk, bread, something like that. But there are a few other things you don't always use. That's in the supermarket. So always have this kind of storage tiring. Okay. Materials and life cycle. Again, use recyclable, low impact materials. Yeah, and designed for repairability, like when something fails then you can repair it, and e-waste management can be done from day one. Yeah. Okay, and energy management in operation. Yeah. So I think some of it we have seen. So you should always monitor the power consumption of each organization or each electronic, and you can always do dynamic resource allocation. Yeah. So it's like I said, if we are here, these ACs should be on, but if we leave, that they should be turned off. Yeah. So this is like two phase. Yeah. But it could also be, if this room is so cold, there could be dynamic adjustment of the temperature itself that can save the power. Okay. Renewable integration. So like I said, these is a lot of energy is produced by renewable resources, but like I said, this is not always available. So when it is available, then basically schedule the task to that kind of resources. So some data centers these days are running like that. So they operate on fossil fuels or electricity, you can say, but there are times there is huge amount of energy available through renewable resources, then energy is taken from that source. And always decommission idle servers. Yeah. For example, there could be lots of laptops, lots of computers, those things, and lot of servers. Yeah. So decommission them. Basically, don't put there. Try to use for some other purpose. Okay. Okay. Let's stop here, and in the meantime, think like what extra can be done. Yeah. For sustainable computing, if you are designing the system or when you are using the system. Okay. Then in the second half we start from there. Okay. All right. Okay. So we meet at 2. Yeah. Okay. Okay. Have a good lunch. See you at 2. Okay, let's start, I think. Yeah. So whoever is coming can join. So we already saw there are lots of things that can be done, yeah, to have sustainable computing. Yeah. I think I just did put this question, what extra can be done? So again, we do not have the text box, yeah, but if you think something that we have not discussed, just you can tell, yeah. Anything you think we have not covered? No? I'm looking my notes just to see if there is anything missing. So we already have covered carbon reporting, yeah, for transparency. So every organization should report how much carbon they are burning, yeah. And cooling and environmental controls, yeah. We have already seen we should not cool more than needed, yeah, or we should not use more than needed energy. I think we also discussed human and process factors, yeah. So humans should be trained, yeah, all regular training is required. There could be also some green procurement policies, yeah. For example, some companies, they advertise, right, their TV takes less power, their refrigerator takes less power. So typically people tend to buy those more, right. So similarly, they can be a bit expensive, but that's better way to do, okay. And there can also be continuous improvement, yeah. There could be periodic audits. So once you report your carbon footprint, it should not be just once, yeah. There should be periodic, otherwise just when you are reporting, you can take care, but not before or after, yeah. And there can also be something called like feedback loops, feedback loop for design and operation, yeah. So for example, let's say you design the system, yeah, and then someone can feedback like what can be improved, yeah. For example, the smartphones, right, all the smartphones for all the kind of people, they are designed in the same way. But if you look different people who are fall into different age category, like the children, like then you can say young people, then old people, yeah. Old people want to use phone in a different way, yeah. They do not want so many apps, yeah. It's mainly for them to communicate, yeah. So I mean there can be some kind of this kind of feedback loop, yeah. So there could be phones maybe much cheaper with less resources, and this can be phone for old people, yeah, and their font can be bigger because they don't see it very well, okay. For children again can be different, yeah, maybe already secure or something, yeah, like they can't use every website, they can't use every software, yeah. For adults, I think it's like the one that is produced, yeah, and everybody is using. So there could be some feedback loop, like what kind of device is more useful for what kind of people, okay. And we can also do some benchmarking against industry leaders, yeah. So there are some industry leaders who work into like renewable energy or carbon efficiency. So it's always good to give the examples, yeah. For example, electric vehicles, yeah. So if you know Tesla, yeah, they were very ahead in the race, and they got lots of profit as a kind of carbon efficiency credits, yeah. So they make a lot of money from that, yeah. So those kind of examples are good, okay. Okay, now key takeaways for sustainable computing from system design and operations point of view. So always try to design smart and always try to operate smarter as well, okay. And sustainability is both a technical and cultural shift, yeah. It's not just we make the computer very sustainable, yeah, it's also about culture, yeah. We should try to use them as much as possible, we should try to turn them off, and there could be some inbuilt mechanisms that can always make sure it does not use a lot of power, okay. And also device should last longer, okay. So the you can say the future can be carbon aware scheduling. Yeah. So always be aware of the carbon in using the resources of the electronics, circular hardware economy. So it's like when something gets faulty, then how it can be repaired, if it not, how it can be refurbished, if not, how it can be remanufactured, and if not, how it can be recycled. So nothing goes a waste. Okay. Yeah. And some of the industries are already doing it, like construction industry. Sometimes if a building is old, it's kind of demolished, but there are mechanisms people extract useful parts, so or like reuse it in kind of some concrete or mixture or something. So similarly for this one can be done. AI optimization is another kind of future. Most of the carbon you can say is burnt to kind of run the AI workload on the hardware. Yeah. So what can be done around it? Okay. Okay. Any more questions? No. Good. So hopefully this gives you good idea to kind of have introduction of secure computing, sustainable computing, and what can be considered when you design them and when you operate them. Okay. Yeah. Good. So with this we come to the last lecture of mine today. There is another lecture, yeah, by Dr. Moumita after this. I think some of you were interested into communications, yeah. So that lecture will cover that. So it's good, like you can attend that. So in this one, we are going to cover computing systems of various scales and their design challenges. Okay. Again, these design challenges we are going to look only from the cyber security and sustainability point of view, yeah, not everything. Okay. So we already have seen this, right? So what is the typical computing systems landscape? Yeah, we said we can have billions of edge devices, yeah, or sensors, small processors. Then we can have millions of servers, yeah, and there could be thousands of data centers. Okay. So this is one way to kind of categorize, you can say. This is the computing system landscape, but there is a kind of another more formal way. Okay. So before going to that, let's look like importance and challenge of scale in design and operation. Okay. So what is the importance of different scale? For example, the edge, yeah, and the servers and the cloud, and what are the challenges into those if you in the design and operation phase, if you want to care about the security and sustainability. Okay. So again, I think I have put a question, what are computing systems of various scales? Yeah. So we already have seen like this, yeah, but this can be kind of further have more fine grained categorization. Okay. So for example, one category can be IoT sensors and embedded devices. Yeah. So this one will fall into that. Yeah. Another can be edge computing systems. Yeah. So edge is called typically you do the processing near the sensor. Yeah. That is why it is edge, or somewhere in the closed premises. Yeah. Don't send the data to cloud. So edge can be again same embedded device, or if these servers are very close to these sensors, then also it is an edge. Okay. The third category can be high performance computing and supercomputers. Okay. So again, these can be a set of servers, yeah, and we are going to look in a bit more details, yeah, and supercomputers can be designed based on that. And the last one can be cloud and large data centers. So this category, yeah. Okay. All right. So now I have put a question, yeah. So can you match here to the right category? So you have a television, a smartphone, PlayStation, camera, this recorder, a car with lots of electronic and a data center. So, which one you will say is IoT sensors and embedded devices?
Almost all of them except servers.
Yes, you can say yeah, like that, yeah. But I would say maybe this one has a camera sensor, yeah, and lots of processing is done there, right? You can see some camera with motion detections and all those, yeah, that is processed at the edge, yeah. And then this one also some processing filtering is done. Here also these days cars have several cameras, yeah, and the decision is done there, okay. Phone also has a camera, yeah, but phone also does a lot of processing, yeah. If you kind of consider old age phones, they were not powerful. So I'd say nowadays phone can be into edge computing as well. There's lots of processing is done on the phone, okay. Okay, what about cloud and large data centers is very clear, yeah, is this category. What about the high performance computing and supercomputers? I think I would not say PlayStation. I would say PlayStation is again like edge compute, edge, yeah. You do lot of control, but then decision is made locally, yeah. I think we will come to the definition of how first we can define high performance computing, okay. And then you will see like, so this kind of thing can be done in a set of servers, but it doesn't have to be cloud scale, yeah. Cloud has like so many servers, yeah. So this can have a limited set of servers where high performance computing can be done, but this can be done in the cloud as well, okay. So I would say there is very thin boundary between these everything, yeah. So lots of people can say this is just one category, yeah, and some people can say this is just one category, yeah. So you can say there is only two category, yeah, okay. We will see like the boundary is very blurry, yeah, we can't really say, but if someone says like okay what categories you can think, I can think of these four, okay. Okay, so first let's look IoT and embedded systems, the first one, we said 4, right. So this is what is IoT and embedded systems, yeah, we are surrounded with, and these are in billions in numbers, and these are small scale devices with limited resources, yeah, and used in smart homes, wearables and sensors, yeah. Now what are the design challenges from cyber security point of view? So you can see these have limited resources, yeah. So you can only do limited processing, yeah. So if you want to do some kind of advanced encryption or decryption, there is not enough resource, yeah. Or you cannot put a very heavyweight software on it that has to do some kind of detection of malware or preventing it, okay. They are also difficult to patch or update, yeah. So again the reason is not they have limited resource. If you keep doing updates, the software can be very heavy, yeah. So that is difficult, and physical tampering risk is there as well, yeah. So like I said, someone can take my device, my phone, and then they can reverse engineer to get some of the data, okay. About the design challenges on sustainability, and these are some listed here, but you can think of more. So the first one is battery waste and disposal, yeah. So that's kind of one challenge, and short hardware life cycles. So if you consider these small scale electronics, they typically do not have high life cycles, yeah. So they do not last for a long time, okay. And they also have resource intensive manufacturing because they are produced in billions, yeah. So many of them need to be produced. Okay, so this is just one kind of case study example, IoT and embedded systems. So this one is from cyber security point of view. So this is Mirai botnet, you might have heard about it. So botnet is kind of a network of devices, you can say IoT devices, but each of them has been kind of hijacked by an attacker, yeah. That means each of them has been made corrupted. Okay. So, if there is insecure network or insecure IoT devices, this kind of things can happen. Okay. So, this is kind of a popular attack that typically happens in a network of devices. Okay. This case study for security and for sustainability, you can say sensor recycling is used in smart city projects. Yeah. So, you can see like sensors are placed, yeah, but they have a lifetime. Yeah. After some point they need to be replaced, but they are just thrown away. Yeah, there is no recycling. So, that kind of recycling can be done basically to have some sustainability considerations. Okay. Okay, edge computing systems. So, I am again putting the same number, same basically devices. So, like I said, there is a very blur boundary between those. Edge is just like there is more processing at the edge. Like I said, phone can be edge example, but a camera can be like IoT and embedded systems. Okay. So, you can say in a way this is intermediate scale between IoT and cloud. Yeah. So, it just sits in the middle. Okay. So, like this phone is receiving some sensor data like my voice when it has to do something, or something in the camera does some local processing, yeah, and then it does not rely always on the cloud, okay, because there could be some app that can do the processing of the image. Okay. And these process data closer to the source, okay, that is why it is called edge. Yeah. Okay. Cyber security challenges, yeah, I think these are again something similar. So, physical access threats, like I said, someone can access. There could be distributed attack surface because there are so many and they can be connected. So, again similar example, yeah, that is Mirai botnet, that kind of things can happen here as well. These has remote management complexity, again due to limited resources, you can say, yeah, not easy to do that. About sustainability challenges, I think about similar like the previous one, because there is limited resource. So, it is not easy to balance the power and performance. Yeah, you cannot achieve a lot of performance because there is limited power. Yeah, and in these kind of devices you need to do cooling in small enclosures. Yeah, imagine this phone. Yeah, if it becomes very hot, the cooling has to be done in this small place. Yeah, you cannot put an AC to cool it. Yeah, that is very expensive. So, you have to think all these, yeah, when this becomes hot, how the heat is going to be released. Okay. So, these are the challenges. Okay. So, now edge computing system case study example. So, this is kind of a question, can you think of something? So, this could be again like from cyber security point of view and sustainability point of view, both. Yeah. Okay. So, do not worry, let us look just. So, any industrial AI deployment, yeah, that is balancing latency, energy use and doing secure data handling, it is basically case of edge computing. Yeah. So, you see like when there is some industries, lot of manufacturing is happening, there is a checking points at each point. Yeah, like whether the mixture has been mixed nicely or not, and after that something has, a component has been manufactured, whether that has come nicely or not, then it is assembled, whether assembly has gone right or not, then there is some kind of other follow up testing or checking. Okay. So, in any industrial AI deployment there is lots of local processing, you see the process and you take the decision whether it is right or not. Yeah. If something is wrong, you discard the device because later on it is not usable. Okay. Okay. So, now I have put a question, can edge computing systems include servers as well?
On-premises servers.
Yes, that is right. Yeah. So, you have to use on-premises server. Yeah. So, for example, like in IIT Guwahati, yeah, there could be few things, few cameras or something, you do local processing, but you send the feed to some local server as well, and then you do the processing. So on premises servers, you can say this is edge processing, yeah. So it's not cloud processing. Okay, good. So it can be, yeah. Now let's see this high performance computing and supercomputers, yeah. So how exactly you can define it? So these are massive scale systems for scientific computing, yeah. So scientific computing is like some people are doing simulation of the earth, yeah. So by that they can know like what is the life of earth, what will be the temperature of the planet in 10 years, yeah. Or some people are simulating like whole human life, yeah. If you have to live like 100 years, what you should do and all those kind of things. So this is basically, you can say, high performance or scientific computing, okay. Yeah. So these things can be done in data centers as well, but data centers are kind of for more generic purpose, yeah. So this is more a specific purpose. So the computing center is designed specifically for that, yeah. Okay. And that is why these require a specialized infrastructure, yeah. Okay. So the design challenges for security. So there is nation state targeting, yeah, because this kind of research is very important. You know, this is one thing I said, but there is also lots of discoveries like drug discovery or something made, yeah. So it's like you put a human tissue, you put some chemical on it, yeah, and you observe how it is changing, yeah, over the time. So then based on that they decide like what kind of compositions should be to make maybe new drug or new medicine or something, yeah. This is how. So lots of people basically, they do not have resource, they kind of want to kind of steal such kind of process, yeah, to know. So so basically this kind of targeting can happen, yeah. If one nation is advancing a lot, others can just try to target it, okay. And this also has issues sensitive research data protection, yeah. So because this is sensitive, so you have to make sure data is protected, okay. And there is insider risks as well, all right. So you might have already seen, I mean, like nuclear, you can say this nuclear machines, yeah, these bombs, yeah. So there is a kind of scientific computing that happens, yeah. Like if you do this kind of explosive, what will be the effect if you kind of do this. So you might have seen scientists are being kind of stolen from one country to another to help the war, yeah. So these kind of things can happen. So insider risks is there. Or you maybe some company did some drug discovery, you might have already heard, yeah, like there are drugs coming like for you can say cancer drugs, yeah, or some other very popular, yeah. So if some company is coming first, others just want the formula for it, yeah, or the process that happened in that discovery process. Okay, for sustainability, I think this is very obvious. These things take a lot of power and they need advanced cooling, yeah. So this has to be considered. Okay, so just I have put a question. If you can think of an example for this one as well. Any example? I think before these data centers came, you might have always heard there is this high performance computing center and it is just doing only very specific thing, yeah. So medical companies, they try drug discovery. Some kind of environmental scientists, they try to kind of simulate the whole planet, yeah. Just like if these activities are happening, or predict maybe when can be the next tsunami, where can be, yeah, when can be the earthquake, where it can be, what will be the magnitude. So these kind of computing, yeah. So it's kind of very specific purpose, okay. So one example is this one, Fugaku supercomputer. As the name says, it should be in Japan, yeah. So this is one supercomputer, and it is ranked high in efficiency despite scale. So it's like a set of servers for a specific purpose. I think I forgot the purpose, what exactly it was for, but it could be for some nuclear reaction simulations or something. Okay. Okay, so the last one, fourth category, cloud and data centers. Yeah. So they are centralized computing at scale and shared by many tenants. Yeah. So it's like each of us can subscribe to one of the data centers. Yeah, or data center resources. And challenges here, there is multi-tenancy risk. Yeah, lots of people are accessing, and in that there could be kind of risk of your password being used by someone else, or like lots of people trying to use the same resource. If there are too many, they may overload the resource as well. Yeah, and then maybe no one is served. Okay, insider threats is always there. I think now you might have got the idea, and there is supply chain vulnerabilities as well. Yeah, so supply chain issues are always there. You can already see like there are trade wars. Yeah, so US doesn't want NVIDIA chips to go to China. Yeah, now I think there is trade war in India, US as well. Let's see where it goes. So, but this is like they don't want NVIDIA GPUs to go there. Yeah, so this supply chain issues as well. Yeah, I mean one I think the long back even Intel CPUs were banned to be exported to China. Yeah, or I think other way around as well. So no, so that is why you can see everybody wants to develop their own facilities, so that the people working there, they do not do something like tamper. Yeah, something is going fine up to some point, and after that it can go wrong. So nobody wants that. Okay. All right. About sustainability, I think it's more or less the same thing. High electricity cost, high cooling cost, and there is issue for the e-waste management. Yeah, so electronic waste is a lot. Okay, nothing much here. So for this one, example can be a Google data center. Yeah, and they did something nice. I think we already have seen. So they did some AI driven cooling, and that reduced energy cost by 40%. So actually if you look the data centers, there I think 30 to 40% cost is the cooling cost. The 60 to 70 is operating. Yeah, so it's like they're running at very high power. It's like so much heat. If they don't cool, then electronics will get burnt. Yeah, so that is why the cooling is very, very important. Okay. So now let's see common security challenges across scales. Yeah, if you look all those four, yeah, IoT and embedded systems, edge devices, high performance computing or scientific computing, and the last one, cloud. Yeah, so these are the common challenges from the security point of view. So patchability and life cycle security. Yeah, so patchability is like, you know, there are patches, upgrades, and all those. This is always a challenge. Yeah, and there is always limited resources at a small scale. Yeah, that is why you need to send the processing to cloud versus high value data at large scale. Okay, so at large scale, basically you have a lot of data or maybe some sensitive data, so there is lot of power to process, but a small scale, the problem is we have limited resource. Okay, and supply chain trust we have seen in detail. Yeah, this is a huge issue. So what do you think can be done to address these? I think some of these we already have covered. Yeah, but can you think like what can be done to address these security challenges? So let's say the supply chain trust. Yeah, how this can be addressed?
To ensure the authenticity of the supplier.
Yeah.
Background checks, doing background checks.
Yeah, authenticity of the supplier, background check, yeah. So, but there is always in this kind of thing some insider threats, yeah. Some engineer or some country sending an engineer that gets employed in that organization, and then they pretend to be like normal employee, but they are not normal employee, yeah. They have a purpose to destroy everything, okay. So that,
Control access can be like
yeah, one of the thing could be, I mean, each country tries to have their own manufacturing, yeah. That is why like US is trying a lot of data centers or own chip, or restricting the chips from their market to go other places, yeah. Yeah, all the things can be done, okay, yeah. And about this one, limited resources at a small scale, again, we can try to process as locally as possible, yeah, so that data is not going away, and so basically you don't need to burn a lot of power in the cloud, okay. Okay, so these are some ideas, yeah. So one thing could be you can have in-depth defense, yeah. Make sure you, whenever an attack happens, you have solid defense mechanism, so that can detect and stop it. There is another direction of research, it's called like zero trust architectures, yeah. So for example, if you get any chip, any electronics from anywhere, assume it's not trusted, yeah, because we always trust, right? We get the phone, we trust it, we use it, and after some time we realize, oh, there is something wrong, my data has been leaked. So always assume there is some problem, yeah. So do not trust it, then you will do some testing, yeah. Then after testing you start using it, okay. Another thing could be secure by design hardware and software, yeah. So typically when an attack happens, then we start thinking, right, how to detect it and how to fix it. But secure by design means let it not happen, yeah. Let anyone not enter your system, let anyone not be able to install any malware into your system, yeah. And if you consider zero trust architecture, even if someone has kind of inserted maybe some trojans or something in the design phase, try to detect it into the testing phase, yeah. So those kind of things. And if you are using any software, do not just install it, yeah. Have some mechanisms to test it, make sure it's 100% kind of security proof, then put on it, okay. Later on we are going to see some of these, yeah. If there is hardware trojan, what kind of problems it can have and how we can mitigate it. If there is a software that has a problem, how it can be detected and what can be done, yeah. So I will introduce some approaches, okay. Okay, so now common sustainability challenges, yeah. I think most of it we have seen, yeah. So energy efficiency versus performance, life cycle and recyclability, and optimizing shared infrastructure, yeah. So these are, I would say, challenges. So what can be done to address these? So let's say you want to achieve energy efficiency, yeah, and performance as well. So how you can do it? I mean, some people design energy efficient hardware, yeah. So there is something called like application specific integrated circuit, yeah. So that does only one kind of a specific job, yeah. For example, crypto mining, yeah. If you remember, there used to be crypto miners, so that can just do one specific job, yeah. So kind of designing a specific hardware, yeah, or also can be like designing a specific software for something, okay. So not a software that does everything, yeah, just a specific purpose, okay. That's one thing that can be done. Let's see what else can be done. So one thing that can be done is modular design. Yeah, I think we have already covered it. Yeah, so you should have multiple modules. If something goes wrong in one, it can be replaced. Yeah, carbon aware scheduling and computing policies. So we have already seen this. Yeah, when you are using resources, always try to be carbon aware, but there could be carbon aware computing policies as well. Yeah, so governments, policymakers can make some policies like, if the company is selling this many electronics, they have to always kind of report how much carbon their products are going to be using, yeah, and what then can be done. Yeah, so and if they can ensure their product is kind of using less carbon over its lifetime, maybe they can be incentivized. Yeah, they can be given some benefits. Yeah, okay. And there could be circular economy for hardware. Yeah, I gave you the example of Rolls Royce, yeah, jet plane engine. So there could be those kind of things. Yeah, making the things that last long and then creating a circular economy around that. Yeah, so creating economy around more, you can say, refurbishment, remanufacturing, recycling, more around it. I think this one in the middle is at the moment missing. Yeah, anything goes wrong, it's a waste. Yeah. Okay. So now, you know, like we looked like sustainability, security in a kind of two distinct aspect, right? But these things has to be considered together. Yeah. So there is always an interplay between security and sustainability. Yeah. So you should do secure updates and extend device lifetime as well. So this is kind of, you know, if you try to kind of meet one metric, you kind of negatively impact other. Yeah. So if you try to make things more secure, it turns out it's less sustainable. Yeah, because you need kind of extra hardware, or you need extra software, or maybe dense of software to monitor things, but then that's all burning power. Yeah, extra hardware is like using extra material, and that is not helping sustainability. Yeah, so try to do in a way like, if you update, make sure maybe it extends the lifetime as well. Yeah, somehow. Okay. And here second point says power saving modes may affect security monitoring. Yeah, so again, you know, in our computer or phones, there is a power operating mode. Yeah, so when nothing is happening, like in my phone, it's in idle mode. Yeah, but if there are one or two apps running, there's a higher level power mode. But if it is a compute intensive game running, it's the highest power mode. Okay, but that is for power saving. But attackers are using that you can say feature to get some sensitive information. Yeah, so it's like if it's running at some voltage, they kind of assume, I mean, that voltage label they use to transmit some information. Yeah, later on I will show you like how this kind of power labels can be used to basically send some sensitive information. Okay, so they do in a way like, you know, they will kind of they will change the frequency of the processor in a way they want to send some information. Yeah, so they will be say like low frequency, that means bit 0. So they will put an extra program that is going to control the frequency. If it's low, they may say the bit 0, and also for some time. Yeah, they will rise the frequency, and then that's bit 1, then again they lower it, and then kind of this they keep doing, and then release the sensitive information. Although this feature is to save the power. Yeah, so it's like when nothing is happening, put in low power, but they can take control of this feature and can send sensitive information. Okay, we are going to see that. Okay, and also secure supply chains enable ethical sourcing. Okay, I think that's not much to discuss. I think some of you also mentioned you are interested into AI, and AI is very good, and if we want to kind of have joint optimization of security and energy. Yeah, so you already have seen the Google data center. Yeah, they reduced their energy bills or cooling cost by 40% by having this AI driven cooling. Okay, Again, there could be AI based resource management. Yeah, so if it's like there are a lot of requests from all the world is coming to one data center, which server, which node, which server they should be using, and inside the server what should be the operating frequencies so that they don't take a lot of power. Okay. All right. So what are the key takeaways? So designing secure and sustainable systems is critical. Yeah. So this is kind of a summary of the introduction of secure and sustainable computing. And we need to have tailored solutions to scale and context. So what is the scale? Like it is embedded device, it is maybe just a camera. Yeah. So we should think of a solution that is just for that camera. Yeah. So scale and in the context as well, what exactly it's doing. Yeah. So what it does, what is how big or small it is, we should think the solutions in the same way. Yeah. Like I said, we don't need a same kind of a smartphone for all the people. Yeah. There is something called like scheduling or governor. It defines the policy. There is something called like scheduling or governor. It defines the policies, but it's not AI based. Yeah. So it can be useful at some place, for example, in data centers. Yeah.
In data centers where we have lots of features from we have to decide like from which shall what try whatever. And
Yeah.
Will be needing another kind of.
This is, yeah, I think this is kind of, you are investing in something, but you put initial effort, yeah, and you have to see whether in long run it can pay off. So there can be some situations it can pay off, but not in all the situations. Yeah. Okay. Interesting. Yeah. So I think the conclusion is you don't have to use AI everywhere. Yeah. You have to find the situation where you can use AI. Okay. Yeah. It's not useful everywhere. Okay. For example, in smartphones, my group developed some, you might know, reinforcement learning. Yeah. So based on and it's like reinforcement learning has again lots of ways to do, right? There's one like Q learning. Yeah. So you develop some Q tables. Yeah. So like some states and actions. Yeah. So we developed something for applications, but it takes a very long time to learn, yeah, the best decisions. Also this because this is very, very dynamic environment, it never finds the best point. So the something more heuristic based approach, they are much better. Yeah. I might cover some of these just to show like where this kind of learning based approach is good and where it's not good. Okay. Yeah. Yeah, so this is very good discussion, but there is again a problem. If you do your research these days, you might have seen if you don't use AI, people think like you are not following the trend or something. Yeah. So you have to basically do some results. Yeah. You have to show the results. Like okay, I used AI, but it's not giving me the best result. So I will not choose for this specific scenario. Yeah. So what I'm saying, if you just do heuristics or some typical approach, people are going to say, what about some AI approach? Yeah. So it's better to have some AI approach and just show how bad it is. Yeah, for that specific scenario.
There was another security challenge that you have mentioned, high value data at large scale data centers. So is there any possible way that we can isolate high value data virtually?
I think data centers, they do that. Yeah, because they do project for some kind of government organizations as well. Yeah. So you see like some kind of hospitals, government hospitals, or maybe this defense sector. Yeah, they also use data centers.
How would it be implemented? Like, would it be like an access control strategy, or some kind of like they like basically provide a different kind of server for them, like separate server? How?
To me, it should always be separate server. Yeah, they don't be sharing the same thing. Yeah, yeah. I think some of the things are very critical as well, right? So that cannot be shut down. Yeah, like there is always kind of insider threat or something. So someone from inside may tamper or something. So I think for critical operations, it will be like dedicated facility for that purpose. Yeah.
If we are implementing some kind of solution for sustainability and energy conservation, wouldn't it be better if we directly implement stuff on wherever we are getting network from, rather than implementing on every devices? So basically filtering and then scrape and then distribute directly. So we don't have to use way too many computers per se in like mobile phones or laptops or etc.
Yeah, it's interesting. I think this is something related to this guy Oracle, yeah, who opened this company Oracle. Yeah, Larry Ellison, yeah. So his idea, he was the first proposer of data centers. So he said, why don't you use big data centers, do everything there, and these computers can be just terminal, yeah, everything is happening there. But at that time, Microsoft has like their own market, yeah, PC, and PCs were expensive as well, and the data center were very expensive as well. So they kept going, yeah. Now you can see these kind of things are happening, yeah. We are putting lots of file on the cloud, and then just doing like remote basically, yeah. So one way is you do lots of things centrally, and then do logging. Everybody gets kind of access computing there, yeah. But the problem is the amount of sensors, yeah, amount of IoT devices or embedded devices, they are much more in number. You saw, right? They are in billions, and then data centers are in thousands. And in future, there are going to be more and more IoT devices and less data centers.
And that's why I suggested like something like an arbitrary Wi-Fi router can have that kind of mechanism.
Yeah, so this is where the trend is going. It should be more and more local processing. So there should be less and less data sent on the cloud, or no data to be sent on the cloud. So I think there is already prediction, like if you look, I think by 2030, yeah. So there will be huge amount of devices, and if you send all the data to cloud like we are sending now, cloud will not have enough processing capability. So around 80% of the data, 80% of the data has to be processed locally by 2030. That is why this edge processing, edge computing trend is coming. So one thing is abundant amount of data from all these devices, yeah. Another reason is basically security, you can say. Nobody relies on, although every company says you are end-to-end protected, your data is safe, your processing is safe, but everybody is developing their own edge computing facility, yeah. Yeah, I think it's kind of all driven by how much data is going to be flowing and how sensitive the data is. Yeah. Good
But
discussion.
like I was just asking about for security purposes, if we are processing a lot of stuff in everyone's phone, there are some general trying to do exploitation and stuff. So rather than calculating in everyone's phone, it would be better if we implement it directly on the router or the system from where we are connecting the network.
Yeah, it can be. I think there is always a reason, like it's more kind of sustainable, you can say, but there could be security challenge. Now it's like there is like a centralized place where all the information is going, yeah. If someone gets access of that, then everything is going to be corrupted. Not everything will work then, yeah. So if there is individual, like one gets compromised, the other can still work, yeah. So I think anything that goes like centralized processing, yeah, it's called something like single point of failure. If anything wrong happens at the central point, everything connected to it goes wrong. Yeah.
We can create some algorithms around it, maybe.
Yeah, it could be maybe you can have multiple routers. Yeah,
So
maybe
like step function would work there.
yeah. I mean, there people have proposed like a distributed way. Yeah, like this many set of devices with this router, and if it's compromised, maybe all of them can connect to something else. Yeah, I think these are all the ideas and kind of approach. Yeah. I think again that is like edge computing. Yeah, like you said, there are lots of cameras maybe in this campus, right? And they send all these feed to a server. Yeah, that is edge processing. Yeah, and then the results are there, and then they may send back the information to these cameras if they have maybe some voice or something. Yeah, they can alarm something or something like that. Yeah. Okay. Okay, that was my last slide. Any more discussions? Very interesting discussions, yeah. Like I said, yeah, I showed you 5 metrics, yeah, performance, energy, temperature, reliability, security. If you want to make one thing better, rest goes wrong, yeah. Yeah, so if you want to optimize for energy efficiency, we should have just very small computer, yeah. But then you can't do everything. You can't secure it, yeah. You can't achieve the performance you need. So this is the problem. We have to basically balance everything, yeah. Okay, that's why I said sustainability is basically to balance energy efficiency with the planet, yeah. Okay, and security I said is basically balancing or ensuring that CIA, yeah, confidentiality, integrity, and trust. Sorry, yeah, availability. Sorry, yeah. Integrity and trust and availability. Yeah. Okay.
Excuse me, sir. I have one question.
Yeah.
Sir, on account of sustainability, as you said that by data offloading, we are reducing the energy consumption of this data center, right? At the same time, when we think in the reverse manner, increasing this edge devices is more like causing that e-waste, right? More. So, what do you take on that one?
I think it's interesting. Again, so you see, we saw some statistics like we say around 4% of electricity is going into electronics. Yeah, out of that 3% is in data centers. Yeah. And 1% is in all the edge or sensors and everything, yeah. So I think because they are already taking a lot of power, yeah, and these edge devices take less power, and that one is taking a lot of power because all the data from these edge devices is going there, yeah. So to me, it's always better to do as much local processing as possible, and also in future we will have many more edge or IoT electronic devices, yeah, than the centralized data centers, yeah. So it's better basically to do as much local processing, although like I see these are like maybe increasing by 1 billion, yeah, every year or every 6 months, yeah, and data centers are increasing maybe just 1,000, yeah. But if you look like the kind of power supply they consume or the number of electronics they use, and like they use big chips, right, not small. So still these edge ones should be very much comparable, yeah. I mean maybe less, yeah. Okay, yeah. Okay, good. Yeah. Anything else? Okay, if not, we can break now. I think it's a bit early. Yeah, I said 3:15 or 3, right? Yeah. So you can take longer break. Yeah, and then you have the next lecture at 4. Okay, by Dr. Moumita. Okay, and she will cover network security. Yeah. So I have not covered network security. Yeah. And in my next lecture tomorrow, I am going to cover more on what I introduced. Yeah, like I said, if you start with a bad hardware, yeah, that means someone inserts some trojans or some circuit that will start malfunctioning after a year or something, what it can do, yeah, and how that can be detected, what can be the mechanisms to stop it, yeah. So those kind of things, and how we can use different kind of side channel properties, yeah, like I said, how we can use sound, how we can use temperature, yeah, or how we can use the timing information to kind of get some sensitive information. So I will briefly introduce these approaches that we have developed in our group, and also some from other groups as well, and then how we can basically detect and mitigate, yeah. And I think we also have the sustainability methodologies as well. So again, I will talk again in my group what we have developed to do in terms of energy efficiency, achieving energy efficiency in data centers or in your phone, in your laptop, all these things, yeah. Okay, more details, yeah. Okay, all right. So you are free now, yeah. I think you had very short lunch, so you can have extra lunch now. Okay, I'm here if you have any questions, yeah.
the time exactly? Left 56. Okay. We'll start exactly at 4. We'll start. We'll start. Nobody else is going to come. So can you guys come in front of it? So you will not come to my office, no? What about the other person? He also wanted to join. Am I audible? Yeah. All right. So, okay. So, if you have been there for the inauguration function, then you know who I am. But for those who don't know, I am Dr. Moumita Patra, and I am an associate professor in the Department of Computer Science and Engineering, IIT Guwahati. And my research areas are more inclined towards wireless communication networks. I work in 5G, beyond 5G communications, autonomous vehicles and unmanned aerial vehicles. Okay. So, in these areas my focus is mainly on resource management aspects, other communication protocols, and some aspects of security is also what I am looking at. Okay. So, today we are going to work or going to see some a bit about secure and sustainable computing, but with the perspective of network security. Okay. So, this session is mostly on network security. What you will find in this session is mostly common with what has already been taught to you today by Dr. Amit. However, today we will see a little bit of a network security aspect. Okay. So, those problems itself, but from the networks aspect we will see. All right. So, if you have any questions, please feel free to ask. All right. Okay. So, the outline of this talk is going to be like this. First, I will give a brief introduction of what exactly is security, cyber security, and hence where do we get this total umbrella concept of network security. So, first we will start with that. Then we will go through the security objectives that we have in communication. then we will look at some vulnerabilities and some attacks, and finally we will see some network security principles. Okay. So, if you see news nowadays, you will see a lot of news that comes around with respect to cyber attacks, right. So many cyber attacks are happening, and so many people are losing their money, and the problem that is most prevalent is that there is no accountability or minimum amount of accountability, and even if there is some amount of money lost, the amount of money that you get back by catching the culprit, that is very minimal. Okay. So it has become a very prevalent problem nowadays. These are some problems or some example news that you can see here, like some Twitter account getting hacked, and then if from Just Dial website some personal data is being exposed. So these are some of the example problems that you have. Okay. So is it problem if I am standing here, can you see? Okay. All right. So before I go to this slide, I would like to ask you questions. What do you mean when you say security? How will you define what is security? This has been done in the previous class, right? So how do you define what is security? Safety from unauthorized access, yes. So basically if I have to define safety, it is like a state, right? State of being free from any kind of threats. Okay. So that's what security is. It could be in any aspect, right? So if I have to define security, it is the state of being free from any danger or threat. Okay. So it could be the safety from some kind of criminal activity like terrorism, theft or espionage, and the procedures that are to be followed or measures that are to be taken to ensure the security of an individual or an organization. Okay. So from this concept of security, we come to cyber security. Okay. So what is cyber security? Okay. It is the state of being protected against criminal or unauthorized use of electronic data or the measures that are taken to achieve this. So when we are dealing with electronic data and its safety, then we talk about, or then we say that it is cyber security. All right. So we have now understood what is security and what is cyber security. Now we will get into a little bit of details as to how we define cyber security. So what is it? Cyber security is nothing but a collection of several tools, then certain principles, some protocols, the actions that you take, the measures that are being taken, some guidelines, some risk management approaches, training, best practices, etc. All of this which can be used to protect the cyber environment and the organization and the user's assets, the user who is using these particular resources. Okay. So how do we define a user's asset? Okay. So an asset could be a device, an asset could be two people, an asset could be infrastructure, applications, services, any of these which is actually connected and communicating. Okay. So the totality of the transmitted or stored information in the cyber environment, that's what my asset would be. Okay. So now my aim is to provide a wholesome security to these assets which are connected and they are communicating. Okay. So this is my objective. Okay. So my objective is to provide these three ideas, that is confidentiality, integrity and availability, which we also call as the CIA Trinity, and we have read this, we have gone through this in the previous class very well. From the perspective of networks, can you tell me what is confidentiality? What do you understand by confidentiality? Do not forget about being networks. Just tell me, what do you understand by confidentiality?
Somebody who doesn't
Hmm? Hmm? Secrecy. Okay. Then
Anybody who doesn't has an access to something should not get access.
that is confidentiality or
That's integrity.
okay. Anybody else? Confidentiality. Can you use that? Yeah.
And something that is personal to someone that they don't want to share with other people outside.
Actually, that's privacy.
Private.
Yeah. So, okay. So, what is confidentiality? So, suppose there are two people who are transmitting some information. Okay. Confidentiality is ensuring that this information is understandable to only these two parties. That's confidentiality. Okay. So, what would be integrity? No, what is integrity then?
Integrity is like ensuring the data that is being shared is not manipulated in network.
Yes. So, integrity would be that the data that you are sharing, that is not tampered or some harmed in some way without your knowledge. Okay. So, that is maintaining integrity. Okay. And sometimes it may include authenticity and even non-repudiation. And the last one is availability. So, what is availability? Making the data available. Alright. How can I not make the data available? Huh? I cannot hear you. Yeah.
Occupied from different resources.
Occupied from different resources.
Because if all the states processes are occupied upon resource, that's not available for them.
Okay. Okay. So, somehow ensuring that the resource that is required for the communication is not available for it to do. Okay. So, that's what he is saying. So, let us get into details into this. So, let us see. Confidentiality is that only the sender and the intended receiver, they understand the message contents. How can I ensure it? One of the ways is to encrypt the message. Okay. Next is authentication. Authentication is nothing but to ensure that you are sure that whom you are talking to is that correct person only. Okay. So, what do you want to do with this? You want to confirm the identity of each other before you start the communication. Then comes message integrity. This is ensuring that your message is not altered without your knowledge. And the last one is access and availability. Okay, so that means the service must be accessible and available to the users who intend to use it. Okay. So, these are my general security objectives. If I want to have a communication, these objectives should be obtained. Okay. So, let us see what are the key elements of cyber security. Okay. So, the first one is application security, that is you can give certain, you can propose certain tools or techniques or principles which will keep the software and devices free of some threats. The next one is information security, which is nothing but what protects the integrity and privacy of the data, both when it is stored as well as when it is in transit. This is network security, and it secures the computer networks from intruders. Okay. So, this is what is going to be our focus in these few lectures that I am going to take. Okay. Now, we have come to know about security, right. What comes after security? If you are attacked, you should be able to recover from it, right. So, that is what comes the next part, that is disaster recovery and business continuation plan. Okay. So, what is the disaster recovery policy? So, if your organization has been attacked, okay, So what is the plan of your organization to revive or recover from this kind of an attack? Okay, and same is for business continuity plan. So suppose you have lost some data, okay, so without that how your organization wants to work. Okay, so these are basically plans that an organization will fall back to while it is trying to operate without certain resources. Okay. Then comes operational security. Those are those protocols or tools which are used to secure an organization from threats, okay, that could be there. All right. For example, you use firewalls, you use intrusion detection systems, those will fall under these operational security. Okay. And the last one is end user education. So that means the end user must know that what could be possible threats, must be able to differentiate between a threat and a non-threat material. Okay. So that's educating the user. So yeah, we will get more into this in the coming slides. Now let's see the next part. Okay. So we have now got to know what is network security. Okay. Now the question is, why do I need it? All right. See, what is the internet? If I have to define internet, what is internet? Medium for communication. Okay. Connecting people. Yes. And anybody? Network of networks. Very good. Okay. All right. So yeah. So this internet was made with an objective that people will communicate with each other. All right. But the people who made this internet were very nice people. They thought that everybody is a trusted person when they are going to communicate. Okay. So all standards and protocols were made similar to that. Okay. But slowly when people started using internet, and it was realized that people are not so good, you cannot trust people, and people can be bad. Okay. So we have to secure ourselves. Okay. So now, sorry, just a minute. Am I audible? Yeah. So now the question is with the internet protocol designers, they are catching up with the attackers. Okay, the different kinds of attacks that could happen, and they are trying to catch up with how to stop this, how to detect the attack, how to localize who is the attacker, how to mitigate the attack. Okay, how to fall back, how to recover from these. Okay. So now this is the question that is there, and hence network security is on the rise now. Okay. So security considerations are required in all layers of the network. Okay. Why this is so and all that I will tell in the next class. Okay. But anyways, let's go ahead. So we have found out that what is network security, why we need network security. So now to have network security, what do we need? What do we need to think about? Okay. So we need to think that how the bad guys can attack my computer. So I need to find out the possible vulnerabilities in my systems. Okay. How they can possibly attack my system. If at all they do, how can I defend from that? And finally, how to design architectures that are immune to such attacks. Okay. So these are the questions that we need to think about. In addition, I will add that how to mitigate such attacks, that will also come into picture. Okay. Now let's come to a very well known network security example. Okay. So I think many of you have come across this example of Alice and Bob. Okay. So Alice is a lady and Bob is a gentleman, and they both are in love and they want to talk to each other, okay, but because it is a private conversation, they want to ensure the CIAs, right? So now the problem here is that there is a third person, that is Trudy, who does not want these two people to be together, okay, or just wants to harm them somehow. So Trudy can be one person who is continuously monitoring their communication, okay. Trudy can also be someone who can, suppose Alice is sending some message, she can tamper the message and send a different message to Bob while acting that that message is from Alice and not from her. Trudy can also be somebody who can simply monitor what messages Alice is sending to Bob to do something different, okay. So what we need to do here is, with this example we will see that what are the different kinds of possible attacks that can happen, okay. Alright, so the objective is that I have a secure sender, I have a secure receiver, I am sending my data over the channels, it could be data or control messages, and there are possible vulnerabilities over the communication channel, okay, and we have to safeguard ourselves from that, okay. Alright, so now in the real world, who these Alice and Bob are representing? They are basically representing two communicating hosts, okay. They could be any two communicating hosts, they could be web browsers, for example, servers, web browser and server for electronic transitions. They could also be online banking client and server, DNS servers, BGP routers exchanging routing table updates, etc. So there can be many examples where two different hosts are communicating with each other. Okay, so we have identified the bad guy here, that is Trudy. Now what the bad guy can do, okay, the possible ways in which the bad guy can harm this communication. First is eavesdropping, okay. The bad guy can intercept messages, okay, and next is that it can actively insert messages into connection. Now these messages that are being inserted could be bogus messages or could be something very different that was not even intended for the receiver, okay. The next is impersonation, okay. So just the example that I was giving that Trudy can impersonate as Alice and send some very different kind of message to Bob saying that I am breaking up with you, okay. So that can also happen. So that would be my impersonation. Next is hijacking, that is taking over any ongoing connection by removing the sender or receiver or inserting himself or herself in the place. Last is denial of service attack, where you prevent a service from being used by overusing the resources or overloading the resource that is there, okay. Alright. So now we have come to know about what possible actions can be taken by a bad guy, okay. So let's see what are vulnerabilities, okay. A vulnerability is nothing but a small a flaw or a weakness in the system, okay. So it could be like some software, firmware, hardware flaw that is there, and it could possibly cause a negative impact, okay. Negative impact on what? On the confidentiality, integrity, or what? Availability, okay, of your system. Alright. Now see, vulnerability does not always mean that you will be attacked. It just gives a possibility that there may be an attack, okay. For example, suppose you are going to sleep at night, but you forgot to latch your door, okay. If you have simply just closed it, the outside person may not be able to know that whether it is closed from inside or not, unless they have some kind of information. So that situation is that you have made yourself vulnerable. Okay. So now vulnerabilities could be in design or specification. So it could be implementation bugs, it could be in also operation and management, where it could be misconfiguration settings, weak passwords, or in general we put default passwords and don't even change it. Okay, so those are the ways in which you are making your system vulnerable. Okay, it's not necessarily that it will get attacked, but it is vulnerable. So now let's see that from vulnerability how are we getting to the point of attack. Okay, so vulnerability means, let me give that same example, that you just forgot to latch your door. Okay, but suppose you were in a hurry and you opened your door and just forgot to even push it back. Okay, so that means you are exposing yourself now. Okay, that's exposure. And next is breach. You had closed your doors, but somebody came inside at night, okay, by breaking the lock or something. Okay, so that's breach. Okay, so these are the three differences that we have. Now see, this is the case, not every vulnerability would result in an attack, and even not every attack is going to succeed. Okay, so exposure is what? It refers to the state where vulnerability is visible or accessible and can potentially be exploited, and breach is an actual compromise of the system leading to authorized access, data theft, etc. Okay. Alright. So now let's get to, so we have now seen that your system can be vulnerable, exposed, or breached. Now let's see from the perspective of attack. So what is an attack? Of course, it's an intentional act by someone for harming you in some or the other way. Okay, so that's what attack is. So what is, and how do I define an attacker? He would be an adversary who is motivated and is capable and also knows of a vulnerability that exists in your system, so that he can exploit that. Okay, so if we have to define it here, an adversary is motivated and capable of exploiting a vulnerability in the system by launching certain attacks. Okay. Now, an attacker can attack in two possible ways: passive attack versus active attack. Okay. So in a passive attack, what would happen, that I am somehow monitoring the system or getting access to the information present in the system, but I am not harming anybody as such. Okay, nobody gets to know about me. Okay, so simply I am just looking at these two people, monitoring them, that's it. Okay, so that would come under my passive attack. Okay, so I am learning about the system. Active attack is I am actively doing something to harm. Okay, for example, your man in the middle attacks, DOS attacks. Okay, now these attacks are very difficult to prevent them because there could be a wide variety of vulnerabilities. Okay, so what you need to do is you just need to detect the attack and then recover. Okay, so that's my goal when it comes to active attacks, whereas when it comes to passive attacks, what the problem is that it is very difficult to detect such an attack, but how you can overcome this is that you can use some kind of encryption to prevent them. Okay, so that's about passive attacks. So attackers could be of different types. It could be individual attackers, group attackers, could be a competitor organization, or your partner turned foe. Okay, and then nowadays I think this word is quite a buzzword, state sponsored. Okay, state or state sponsored actor and all that. Not a buzzword, it's the reality actually. And then the next one is the capabilities that are there. So let's see, the capabilities that are there for required for an attacker is that, one, the attacker must have time to check, okay, to monitor, must have money to do that, okay. Next, should have training, enough training to do the attack, and last is should get the access. Okay, so these are the capabilities that are required for an attacker. What's the motivation? Not always money, sometimes it's just curiosity. Sometimes, when they are teenagers, everybody wants to be a hacker, right? I'll become a hacker, right? So that's some curiosity. Let's see what happens. Let's see if I do it, something like this. So that is that. Sometimes people want to do something for fame, okay, that I will do this, I don't want the money, but if I do such a thing, people will get to know that, oh, this was done by this person, so that will be a big fame for me. So that's that. And the last one is national interest, okay. Alright, so for national interest, the example is what Dr. Amit gave in the morning about the Israel and Iran, yeah, the nuclear power plant. Alright, so now we will get deep into the different kinds of attacks, okay. So first one is the eavesdropping attack, okay. Now it is assumed that by default everything is transmitted in clear text, including your username, password, etc. And there is no security that is offered by the transmission medium, okay. Now you will do this in your tutorial also. I'll take another tutorial on Wednesday where we will see with Wireshark as to how the packet traces are going, okay. So that we will see in the tutorial. So yeah, these are different tools that are available on the internet with the help of which you can actually monitor, okay, the traffic. Then so with the right equipment, even for wireless networks, you can do eavesdropping, okay. So what does it affect mostly? If I can do this, it will affect the confidentiality of my data. And how can I avoid this? I can provide solutions with respect to encryption, and for wireless networks I can use some measures with respect to the signal handling techniques, so that I can avoid confidentiality compromise. Okay, so the next one is spoofing. Okay, can anyone tell what is spoofing?
Phishing.
Spoofing and phishing are same. Then spoofing, what is it? It is given in the slide, no?
Like an impersonation.
Kind of an impersonation, yes. Okay, so what's happening? Injection of a packet with false source address. Okay, so like Alice and Bob, if you want to go back to that same example, so Trudy is actually saying that no, it's not Alice, it's me. Okay, so she is sending that breakup text to Bob saying that it is Alice. Okay, and then Bob becomes sad and breaks up with Alice again. Okay, so that's spoofing here. Okay, anybody knows what's DNS spoofing? DNS spoofing? Huh?
DNS is basically an address book for like famous websites. So like they can inject like a different address in that address book.
So suppose I want to go to Facebook, okay, but somebody spoofed in between and sent you to some X website, okay, I don't know, with some website, okay, something different also could be there, okay, it could just send you to some other. Okay, so the next one is a man in the middle attack. It is exactly what the name says. Okay, so what does it do? The attacker intercepts the communication, okay, and after intercepting, it can do anything it wants. Okay, so this actually affects the integrity, the availability, and the confidentiality of the communication. So an example is that fake Wi-Fi hotspot stealing credentials. Okay, so you are saying when you are opening your Wi-Fi, possible Wi-Fi access points, you can just create yourself as a fake Wi-Fi and then steal credentials from people. If you want outside, if you go, if you have to use Wi-Fi access, you might have to pay also for that. So in that case, if you pose yourself as a fake Wi-Fi access point and then somebody pays and you get the credentials, and then you can do whatever you want. Okay, so that is man in the middle attack, and it is an example, just an example here. This is denial of service attack. Okay, this affects the availability part of it. Okay, that means you are making the resource unavailable for the intended parties. Okay, so here the example that is given is a distributed DOS which is using multiple machines. So here it is something like this. There is a server that is shown here, okay, and then multiple machines are actually sending fake requests to this server, overwhelming it. Okay, so then if there is a genuine request that is coming, then the server will not be able to serve that particular request. Okay, so that is here is as the example is given of a DDoS attack. Similarly, a DOS attack will be also there. Now, okay, now gets your phishing. Okay, so phishing are basically those faking some website or some email or something like that. For example, you get a fake email posing that you are from I mean, it looks very genuine, okay, like it is from a bank or something like that, and you ask them to go to a particular website, click a link and go to a particular website, okay, and then get their credentials and do whatever you want to do. Okay, so yeah, using social engineering. Okay, so this is phishing, and next is an SQL injection attack. Can anybody tell me what is an SQL injection attack?
To use some sort of constraint that will always pass the SQL query. Like suppose you are given a text field, and I insert some sort of a query so that when this is covered with an SQL query, it could give access to the database.
Yes. So okay, so as it is given here, it is inserting some malicious SQL queries into forms. Okay, for example, let me give you an example. For example, you have given some query like from the user you are taking, okay, it's a form, and from the user you are taking some SQL query, okay, but in the back end when you had prepared it, you did not stop any query saying select star. Okay, so now if there is an adversary and gives select star some username or something like that, then that user will get all the information of all the users. Okay, so that is an example that I am giving. So yeah, so this kind of attack can reveal or modify sensitive database information. Okay, so as the diagram is given here, so a hacker will inject malicious SQL query via input data, and then this malicious SQL query is validated and the command is executed by the database, and finally the hacker is granted access to view, and it can modify the records also in the database if the access is given. Okay, so that's SQL injection. Next is a replay attack. Okay, so what is replay attack? That means you take the information of a person and then use it for your own benefits. For example, the user is having a communication with the server, it is opening some website or something with its own user ID, password, etc. Somehow in the middle there is an adversary, it sniffed the communication, got that user ID, password, and then it can use later on to access that same user's credentials to do whatever it wants to do with that. Okay, so this is what we call as the replay attack. Now how can we avoid it? We can create generate the password for a particular session. Okay, like it will be live for only this much amount of time, and then after that if anybody wants to use, cannot be used, and you can also add some amount of encryption also with that. So this is my replay attack. This I think has already been told. Okay, So what is ransomware attack?
Basically a malware which stops the denial of service and ask for some money or some kind of to use the service again.
Okay. Yeah. Anything else? Yeah, ransom, in the name it suggests that you are asking for some kind of ransom. Okay. So for example, you used a malware and you stopped the access to the server itself for the users for some time. Okay. And you are saying that if you pay me this much amount, only after that you can access the server. Okay. So that will be my ransomware. Okay. What is a malware?
Malware is basically a malicious code.
Malicious, yeah, malicious software. Okay. That can be used for multiple purposes. Okay. Anybody knows? Acha, here it is written. Malware includes viruses, worms and trojans. What are the differences between these three?
Trojan is a hidden virus, you can say.
Hidden virus.
It appears to be a software that is friendly,
Hmm.
but when you run it, in background do some work that is not intentionally done.
Okay. And worm?
It can replicate itself.
Worm.
Worm.
Okay.
Make multiple same copies of one
Okay.
file.
Okay. What is a virus?
Can replicate.
Okay. What is a virus? Is there any difference between the three?
The virus can also modify the content or change the.
Yes, they can. Worm can also do that. Then we have been hearing these terms for a really long time, since childhood, right? That virus, worm, this, that. So, anything? Okay, so virus generally is dependent upon user action. You are doing a double click or you are clicking on some hyperlink that they have provided. Okay, so that's a virus. It has to be associated with some user action. Worm is not that. Worm can replicate itself. Okay, and Trojan, what you exactly said, that it looks like it is a genuine a genuine content, but it is not, and then it can cause issues in your system. Okay, for example, if you go to certain sites, download here, download here, download here. You went to download some songs. No, earlier we used to download songs from different websites, right? So there you will go, the actual download button is never found, it will be somewhere hidden, but several other download buttons will be there and they will cause issues in your system afterwards. Okay, so this is an example. So yeah, it is given here that the bad guys create ransomware themselves or buy or lease it from other cyber criminals. The cyber criminals use social engineering to gain access to your system. Then they use the malware to digitally encrypt all your IT systems and data possible. And then the attackers use your encrypted or sensitive data as leverage to force you to pay a ransom. That's ransomware. Okay. Okay. And in some cases, the attackers will exfiltrate your data prior to encrypting your systems. All right. All right. So, see, earlier it was bad guys, okay, now it is changing to worst guys, okay. So, worst guys do insider threats. Why are they called worst? They are anyways bad guys, no? Earlier they are bad guys who are doing eavesdropping, man in the middle, etc. This guy is the worst guy. Why? Yeah, so they are breaking your trust. So that's worst. Okay, worse than being bad. Okay, so that's insider threat. Okay, examples: employees are misusing the access. And why it is worst? Because insider threat is always difficult to detect and even act upon it. Okay, all right. So yeah, before all these network principles came into picture, in history also you can find a lot of insider threats, right? Because of it, so many battles have been won, so many battles have been lost. Okay, so yeah, insider threats. Now why it is more difficult to detect is because insiders already have a legitimate access to the data of that organization. How they make the system vulnerable, knowingly or unknowingly, is that if you are an employee of a company, you are given access for remote working, okay, remotely working. Then also, you can use it on your personal devices. Nowadays everybody can log in through phone, okay, to their systems. So yeah, so remote working is also provided, and also that it might so happen that you are using some third party applications which is not secure, okay, which is making your system more vulnerable. Okay, so in that case you should have a very tight security. Okay, so that is insider threats. Now let's see the different types of insider threats. Okay, so one is malicious insider. It has a bad intent. It came to you from maybe some different organization posing as a good person, and then after coming to your organization, that person is now taking all the information and selling it to them. Okay, so that's a malicious insider. Negligent insider is like, yeah, I don't care, I don't want to log off my system after my day is done, I'm just leaving because I was in a hurry, I had to go to a movie, something like that. That's a negligent insider. What's a compromised insider? Any idea? Somebody getting blackmailed. Okay.
Like we trust someone.
You are trusting someone in the sense?
Like I'm using my laptop to you.
Giving your laptop, yeah. So you're compromising the,
Privacy and
yeah, security of the system. And any other? Nothing else? Okay, we'll go with these examples. So a compromised insider, and sometimes an accidental error might happen. So you forgot that you are working with the company's system, and you just inserted a pen drive that is having a lot of viruses in that. Okay, and it caused issues with the system.
Or we can click on some malicious email ID.
That also, yeah, by mistake it showed that work email, but then you clicked it and then it caused issues. Huh? Okay, phishing. Yes, so these are the different types of insider threats. So we have seen a lot of threats now. Now we will get to some security principles. Okay. So what is the motivation? That I want to protect the entire system by following the CIA triad that we have seen. Okay. But what is the challenge in that? Okay. The challenge is that it is very difficult to balance strong security and usability. Okay, while keeping up with whatever trends of attacks that are coming into picture. Okay, so you are always running behind. Okay, most of the times that is what happens. Okay, so that's the challenge. Now let's see. So the first thing we have already seen, the CIA triad, that is confidentiality, which ensures only authorized users can access data. Okay. Integrity, which protects the data from being altered without detection. You can hash the data, this is an example. And then comes availability, okay, that is the systems and data must be accessible when needed. So you try to avoid any kind of DOS or DDoS attacks to your system. Okay, so there could be systems which need to provide all three of them. and that is, you for example, online banking, which requires all three of these, private access, accurate balances, 24/7 availability, etc. So that's the CIA triad. There's one more principle that we need to see, and that is the AAA: authentication, authorization and accounting. Okay. What is authentication? You have to authenticate yourself as the genuine user. Okay. What is authorization? Huh?
Should have the access for that.
Should have the access for that. For what? For doing something. Like how much access you have. Okay. For example, in online websites, when you will go, there is normal user, there is elite user. Elite user has access to, when the sale comes, 1 or 2 days before they will get access and all that. You do a lot of online shopping, huh? Okay. So our friend here told that 12 hours before. Okay. So if you get elite access, you can do 12 hours before. And the last one is accounting. So tell me, what is accounting? Okay, so you are doing online shopping, no? But you also get to see now that what you have seen previously. So whatever your footsteps or footprint was there in that entire website, that is being monitored. That is what accounting is. Okay. So yeah, so authentication is, it proves your identity, could be done using passwords, biometrics, tokens, etc. Authorization determines what resources a user can access after authentication. Okay. So I can go to a website, but I cannot access what is happening in its backend server, right? I have limited access depending upon what kind of user I am. Okay. Then comes accounting, that is the process of tracking and logging user activities and resource consumption. Can you tell me in terms of, I gave an online banking example, no? In terms of online banking, can you tell me how these three processes, what activities do they look similar to? Okay, what activities do they depict in an online banking system? Authentication, authorization and accounting. How will you define?
For authentication, we can only sign into our bank account. For authorization, we can apply for loan, but we cannot approve our loan ourselves. And for accounting, we can take account for transactions we do, and that's.
Yeah. Anything else? Something similar. Okay. So yeah. So you have to first give your username, that is who are you. Authenticate, that is are you really who you claim to be, that's up to the authentication part. Then comes the authorization part, that is what are you allowed to do. Okay. Then finally comes the accounting part, that is what did you actually do throughout the session that you were in. Okay. So yeah, logging into your bank account, then accessing your money only, that is authorization. Then maintaining a comprehensive record of user activity for auditing, that is accounting. Alright, so these are my AAAs. And the next one is, okay, this also falls under principles, that is a public key infrastructure. Okay, anybody has an idea of this? What is a public key infrastructure?
Basically, public key is a key that we can share with anyone, and there is a private key which we should keep to ourselves to log in and do which is used for authentication. Authentication for.
Okay. So basically, it is used for encryption. Okay. Now, what exactly is happening here is that I don't want to send my message or whatever data I am sending as a plain text. Okay. I want to ensure confidentiality, so I want to encrypt it. Okay. Now, the other party also needs to understand what I am sending. So, this is a very basic idea. So the idea is that the receiving entity has declared a public key, okay, that is known to everyone who wants to send it a message. So what they do, they take this public key, encrypt their message with that, and then create a message in ciphertext and then transfer it over the insecure network. Okay. Once it reaches the receiver side, it will decrypt the message that is received, but with its own private key, which is related to the public key that was advertised earlier. Okay, and then gets the actual message in plain text. Okay, that's the entire concept of public key infrastructure or PKI, and it mostly is used in HTTPS. Okay, so this also we will see in our next class when we see TLS, etc. Okay, so this is public key infrastructure. So yeah, I'm mostly on time. Yeah. Okay. So all right. So to conclude, what we have studied so far is that, you know, network, how important network security is when it comes to communication, and we have also studied about the CIA triad. Tomorrow in the next class we are going to talk about security in various layers. We are going to talk about operational security, and I'll see if time permits we'll get to wireless network security. Okay, so now is the time for questions. Okay, any questions? No questions? No questions. Okay, so in that case I will conclude the session for today. All right, do we have any questions in the online session? No, doesn't look like. Okay. All right, so thank you. We'll see you tomorrow morning. Tomorrow's session will start from 9:30 a.m. Okay, please be here. All right. Okay, thank you. Oh, these are the references though, if you want to know. Okay, tomorrow's class I will see. And then